It's going. Yeah? Yeah? Okay, we're here.
Hi, everybody.
Sarah and Mark are live, and it's a late night podcast on a Monday, and we just ate our tacos for the evening, so we're nice and full of protein and energy, and we're ready to route a circuit board tonight. Yeah? And I have Mark here with me because no one knows how to route a board better than Mark. He's like a aficionado at doing the board routing. Wait, I have to send a link to to my friend so that she can watch this ensue. There? Is that where I can send her the link? Will she get it? Nobody knows.
You never know.
I never know. I'm like, hey friends, watch me stream. We're gonna be doing stuff. Woo! I don't know. I'll start talking about what I'm doing tonight once I see
Is
people.
Is your other friend gonna watch?
Oh, that one?
Yeah.
I don't know.
Watching already?
Here, we'll just there.
There. Okay.
Okay. Everyone's been informed. I think Discord. Let's inform Discord.
Discord.
Link or it didn't happen. There. Take it. Okay. Cool. Hi, Tanner Pearson. Circuits, yes, I need to learn more. Okay, we're routing a board tonight. I can probably switch over to my desktop screen, maybe? How am I gonna do this gracefully? So Mark's looking at...
I'm watching a video about deepfakes. Anyways, just going through my Facebook feed.
All right.
I've been all day.
Well, all right, let me show you what we're doing tonight. So I'm working on this project that I'm calling the she-bone. I don't know if I haven't announced it yet. I haven't actually given any details as to what it is, really. But it's a wearable, and it's going to be a series of wearables. But this one particularly that I'm making a circuit board for tonight is it's a should I just say
electric what?
It's electric salmon. We're putting circuits.
Salmon, but what's it? What part of the clothing body is it?
It's a pair of underwear. It's a pair of panties.
It's electric panties
that you wear, and there's a speaker inside of them, and it will whisper to your nether region at a volume equal to your heart rate. So it involves hooking up a heart rate sensor, an op amp, an SD card reader, and a speaker, so that all these things can happen in conjunction with one another, so that your parts are sufficiently whispered to at the proper volume, at the proper time, which is important.
Why? Why would you do that?
To sense and respond and indicate your arousal state.
So to let your friends around you what your arousal state is.
Yes. So I'm creating a series of
I like that.
Wearables this spring.
I like to know things.
I'm creating a series of wearables this spring that involve indicating to nearby others whether or not the wearer of the wearables is aroused, maybe, which is going to be a tricky thing to do, particularly for females, because I don't know, we don't have as clear-cut, like obvious of an indicator of our arousal state as perhaps males do. We don't have, I don't know, we don't have as physical of a indicator. So I'm creating some fun, perhaps awkward, perhaps honest wearables that will let people know what's really going on. Yeah? Yes. So it's starting with the salmon. So I found out, and I'll stop talking here in a second. Here, let me show you guys something other than our faces. Desktop. There we go. There we go. Concept art. Woo! So I'm calling this board the Fillet-O. And it's gonna look like what? Fillet-O fish. Salmon fish. It's going to look like a cross section of salmon on I don't know. This is going to be a circuit board. It's going to have the fat marbling, and it's going to be responsible for doing all the fancy stuff that I just talked about. Should I look this up and show them, or do you think they care?
Yeah, I think that's a good context.
Okay, I'm going to show you the actual breadboarded circuit here in a second, that I'm going to be routing in Eagle here in another minute. But this is the concept sketch for the Fillet-O, and actually, pulse pack. There we go.
Do you have enough USB outlets?
Maybe
a USB charger outlet or some other.
For what?
To hook that up.
Oh.
What's the power source?
I'll just unplug my mouse.
Okay, you don't have like 8 cameras and all the crap plugged in.
And then the pulse pack is going to be another entity. This is the brain of the whole arousal
Cheeky.
wearables. What?
Cheeky.
They're butts.
I like butts.
Yeah, this is the thing that's going to be running the fillet of salmon, and this is the pulse pack. So this is something else that I'm making, and the two are going to kind of work in conjunction with each other. The salmon is powering a peripheral, and the pulse pack is the brain backpack that's going to run all of the peripherals that I end up making, however many that might be.
Right.
So this is another thing I'm going to be making this spring. In fact, I just got the plastic that's going to make this backpack. We can't see it, but they can.
Okay.
They're good. And that's another thing, yeah. But that's for another night.
Okay.
Anyhow, minimize this and go back to our lovely faces.
On with the show.
On with the show. I'm gonna switch down to the bench view for a second. I actually have to, if you wouldn't mind, will you grab an Arduino?
Arduino?
There's one behind you on top of the tape box, and these things with the flags on them are marked with the pin out things that they need to go to.
Just this one here?
Yes.
Just the white one?
Just unplug the... Yeah. Okay, so I have the circuit that I'm making in Eagle tonight with Mark. I have mocked up on the bench, and I'm just going to show you what it does real quick so you have some context for what we're designing in CAD. That'd be helpful, right? Who else is in here with us? Oh shit, Taylor's in the chat.
Hi, Taylor.
Hi, Taylor. Hey, Maker Block's here. Hi, Maker Block.
Hey, Maker Block.
Cool, and Pullis Squallis is here, and Marble. Oh my god, Marble Gray's in here.
All the people
Hi!
Here.
Oh my god, it's a party. Everyone get your beer on.
It's a fish party.
Here, hook this up.
All right.
See the flags?
Do you need to reprogram that first, or are you going to just... Like, I don't know what pins you're using, so you don't really want to actuate pins that you don't want actuated.
You're no fun.
So plug that in, program it, then plug the...
Okay, there's a USB cable on the ground. Mark's my helper.
Igor.
He's my Igor.
Igor.
Oh, I have new glasses on, by the way. These are brand new. I got them today. They're like...
see now.
I can actually see things. That's good. And they're cat eye. See, they're all like pointy and stuff. Okay.
Is that right?
All right. So I've got on my person right here an Arduino board or an Arduino clone that I named Figaro. I don't know if anyone can see that.
Figaro.
Don't worry about it. Figaro.
Figaro.
So I have a bunch of these now, so I decided I needed to start naming them. All right. So inside. Figaro. Okay. So I'm going to pull up the code for this, which is Shibon code. That would be Beatbox Wave Test. And I can probably go to my desktop view now so that you can see what I'm doing. Oh, it's opening.
Wow, I like that.
It's like an infinity. There we go.
That's
crazy, right? Oh man, there's like a million things. There's probably some like graceful way to do this, but I'm not known for my grace. Alright, so we're gonna upload this to my board real quick. Is it doing? Wait. Maybe?
Compiling.
It's compiling. That's too long. It shouldn't be compiling that long. Uploading.
It's new.
Oh. Is it because the board is a knockoff?
Uploading.
Oh.
Uploading, wait.
No.
Did you change the board there?
No.
Oh, it says not responding.
Wait, it's USB. It's uploading to the wrong bullshit. There. Wait, do I have
problem uploading?
Wait. We were trying to upload to some weird bullshit yesterday. So it's wait.
It's an Uno, right?
Yes. Because I was trying to upload to Tony's
Demalova.
Dillamilanovis. I don't know. You can't pronounce that one.
Problem uploading, do board.
What?
Use up.
What is it?
Did you have to reset the port again? No, it's right.
Let's try this again. Yes. Anytime I want to like use an Arduino and I'm streaming, it's like
thanks,
it's
Massimo.
like, no, don't say that. Arduinos don't like me. Really? Why is it having problems?
Does it make that window bigger so I can see what error?
That's it.
Do you need to hit reset right before you do it?
No, it should just work. Meh. Going? Oh, done.
Yeah.
Okay.
You had to reset. Okay.
Fine. Okay.
Right.
Will you plug the pins on this?
Oh my.
There's only a few. Look.
Okay.
Look. It says 9. Here, I'm gonna even like point the camera down so everyone.
Oh, they're labeled with the number.
Yeah.
That's a 6. Or a B.
That's a 9.
Okay. I'm just checking.
Here, I'm gonna point
Don't
this.
work at NASA.
Shh. There. What's Mark doing?
9, 10, 11.
Here's pins. Oh, that's something else.
4. Oh god, that's the other side. Ground. G and D. Is that right?
Sure.
And 12, 13. Okay, skip 2. Okay. And then 4. 4's over here.
Wait, can I have this hold itself? So I'm not suffering.
Just a few. Lies.
There's like 3. Oh my god, I'm gonna make everyone out there in TV land vomit.
Okay.
This is how we roll.
13. My god.
Animal print pants out of control, man.
The challenge is to make something that uses all the pins on the Arduino.
What?
Win $10,000. I'm not gonna. Right.
Are you gonna do it? Are you gonna do the hackaday thing?
I'm gonna need to talk to you about that.
Maybe.
I'm not good with like thinking of things that are like people would find useful.
Let me look at the chat while you're plugging. Okay. Oh man. Stream glasses. Your new glasses look awesome. They fit your face very. Thank you, Marvel.
All right, is that the whole? Is that all of it?
I think so.
I think that's all of it. All right. So plug it in.
Yes. Is it plugged in? No.
You unplugged. Where'd the end go?
It's right here.
Okay.
Ooh. You should. New glasses are fun glasses. Ooh. It's gonna whisper a test wave. So when he presses, is it gonna do it?
Mm-hmm.
That's not making a noise.
Mm-hmm.
Is everything plugged in?
Mm-hmm.
There's something missing over here, I think. Wait.
The ground. I put a ground. I put the ground on the other side, but that should be fine.
Yeah.
13. Oh, that's not. Alright, I'm off by a pin. Sorry, my bad.
Okay, so what this is going to do once he plugs it in, it's going to whisper a test file that I put on the SD card. So if you look at the circuit, there's this little shiny piece right here. That's a micro SD card reader, and I put a test wave file on it of me whispering some creepy things, and then there's this really ghetto speaker that's taped to the... You can't really see it. Oh, that's too...
You want a microphone?
Yes. Wait. Oh, it's super quiet now. Why?
Is it?
Yeah, it did it, but it was super quiet. Press reset. Oh god. It's really quiet. Why is it so quiet? Ooh, Mark, why would it be so quiet now?
I don't know. This is janky.
Oh, man.
Okay, you need to put the microphone. Where's the microphone? On the camera?
Sure. Here. Okay, I don't know why it's really quiet now.
Right. Show them the circuit first.
So this is the circuit. Oh man, that's big. Woo! Okay, so there's a pot right here, And that's for the volume. That affects the volume.
It doesn't do a very good job of it.
It's not doing anything right now. Hang on 1 second. Let me press autofocus back on for the moment so that it's not all blurry and shitty. I apologize for that. Autofocus. No. It doesn't care.
There we go.
There we go. Okay, so there's the SD card reader right there. It's that tiny little shiny piece right on the end. There's a bunch of caps here. Mark can probably explain what those are doing a bit better. One of them I know is a filter that's helping the audio not suck, although it's not really pulling its weight right now. And then taped on the end there is just a crappy little speaker. I'm going to be mounting something very similar to this in the panties that will be facing the, I don't know where your panties go. It's just a longer speaker, but that's basically what I'm routing today. There's not a whole lot to it. There's an op amp floating around on here somewhere. Where's the op amp? There's a little black thing. So the op amp is pulling the weight. It's the thing that's making the speaker do what a speaker do. And then there's the SD card reader, which is just hooked up to the Arduino, and it's doing what an SD card reader does. And kind of right out of the chute, this just worked, so I'm copying it verbatim, although it is kind of quiet right now.
Right. So put the microphone right up against it. All the way.
I can barely hear that. Why? It was really loud the other day.
We're going to debug that at some point and figure out if it's just, you know.
I love it when stuff goes
we found an amp schematic online, and then we hooked it to the Arduino, and
it totally worked.
It actually, what somebody on their Arduino website posted didn't work, because the thing that was missing is, and Sarah alluded to this, was we're sending what they call a PCM signal to the amplifier. And PCM is called pulse code modulation. And so we're reading a wave file off the SD card and then turning, and a wave is this PCM bit stream of what the wave's amplitude is. But it's a series of ones and zeros. It's not an analog wave. But if you filter it, a low pass filter with a capacitor, which is what we did, suddenly those ones and zeros turn into a actually varying voltage, an analog voltage, by adding this filter, and then now we can hear it. But when we didn't have the cap on there, all we heard was hissing, the digital hiss.
But why would it be really quiet now?
I don't think it was all that loud to begin with. So.
It totally was. Like,
was it?
Yeah.
The thing is, your breadboard, if I wiggle wires on your breadboard, I hear static on the speaker, and that tells me that this old breadboard probably has a lot of oxidation and the wires aren't all that great. So, they're not the best connections.
Could it be the Arduino?
I don't think so. I think there's probably some better, like if we look at the amplifier chip that we use, the gain of it, because we're amplifying an Arduino's volume level to this speaker level, and we need to look at that again and make sure that we're doing the gain right. That's my theory that I'm working on. So we just got to take another pass at it to figure out why it's not super loud, because it should be. It should be uber loud. So I may have to get it on the scope on the bench and look at some waveforms and see what the hell's going on, and tune that capacitor value too. So.
This isn't going to affect the thing I'm making tonight, is it?
What do you mean?
The circuit?
I think it's just value changes. But before we send the board out, maybe we'll throw it over there on the bench and we'll see what's going on and see if we can do anything about it at the last minute. Otherwise, yeah, you're gonna you're gonna have enough connection points that you could solder on what you needed. So I wouldn't worry about it too much.
It was totally loud the other day when we first got this working.
That means it'll be loud again someday when we figure out what.
Would a bigger speaker make it louder in a pinch?
Perhaps. Those might be just. I remember these. These are the ones I gave you, right?
Yes.
These were made for laptops to be able to be loud enough to hear on a laptop. So
I swear it was louder, like two. Fuck it.
So I don't know. I don't know things,
So I'm trying to get this circuit and then the other one, the heart in the backpack, finished this week so that I can have them made and then receive them back, and assemble it and test it and put it in the panties and the backpack before I go to Tokyo next month. So I'm going to Tokyo next month. Yeah? Yeah? And I'm going to walk around Tokyo wearing these things,
You're
conceivably.
done with this, right?
Yes, we can.
All right, I'm going to unplug this so it's not a liability. All right, and then you can have your mouse back if you want.
Yes, we need that for board routing. That's super important. Okay, mouse is back. Okay. Anyhow. I do need more workspace. I've been reading the chat while Mark was explaining, and Tony's harassing me saying I need more workspace. I totally agree with you, but I'd just fill it up with projects. So hopefully this summer I'll have more. I'm just gonna scroll through chat real quick before I dip down. Oh, Tanner Pearson said that. Oh, thank you. I'm glad that. I mean, for the small amount of time that I was on Mythbusters, I'm glad that you enjoyed me.
Yeah, it would be nice to get more episodes.
A lot more episodes. I wish I had more airtime for the one episode, though.
Yeah, that was a rush job. I was not happy with that episode. There was no character development. I thought they would totally do some character development, then get into like an episode just to develop characters.
That's another discussion.
Meh. Hollywood.
I don't know. Well, I'm glad you're here. I'm glad you're here hanging out with us. Uploading Brain to MySpace. Sorry, I just want to make sure I don't miss anything before because once we start board routing, I'm probably not gonna look at the chat as often, and I want to make sure.
Let's see if we can bring the chat on the phone.
Oh man, I need another screen. I don't just need more workspace.
What is that? YouTube?
Yes. Sweet.
Let's do this.
Yes. Electric Salmon. Mark needs glasses. Vi says you need glasses.
I got the surgery.
He got the thing where they shave your eye off and then you can see again.
Yes. They literally ablated the surface of my eye, used a laser, and then that surface grew back after they said it would be a few weeks, but it was actually like 3 years. So.
Aw. Sweet. How are you guys doing? Maker Block, Taylor, Tanner, Marble Gray, Vi Gray, Tony, if you're still there, Tony. How are you all doing? I know two of you in this chat right now are packing tonight. So how is the packing going? Or at least you should be packing. Because if you're not, then I'm going to call you up and yell at you. And Tony, did you eat your veggies? Yeah? You get points if you ate your veggies. I'm gonna dip down.
I'm trying to get to your chat so I can kind of talk.
All right. I'm going down. So this is infinity view for just a second, and then I'm going into Eagle. And I'm going to show you the thing that we're going to be working on tonight. Oh, man. All right. Mark. Brain. Yeah?
Yes.
Behold this. Tony says he had pierogies.
Tony had pierogies.
I'm jealous. We had...
Vigray says that you should use 30-second sound bites of porn videos.
I'm having everyone I know come over, and you can participate too in this if you want, Vi, if you're interested. And anyone else in my Discord land that wants to bite on this. I'm inviting everybody to whisper, like, random shit. It doesn't have to be, like, creepy pornographic shit. It just has to be, like, humorous, witty... Or not even humorous.
They have people send you in sound bites, yeah.
Just send me a sound bite of whatever. It doesn't
Whispering
matter.
something. It can be how a circuit works.
Or anything. Like, you can tell me
some piece of philosophy.
The stripe values on resistors and what they equate to.
How the circumference of the Earth is calculated.
As long as it's
in your best Carl Sagan voice.
As long as it's a whisper, like Carl Sagan whispering.
Yes.
And then this is...
Right.
It's going to be put in a WAV file on the SD card that I just showed you, and that's the thing that's going to be whispered to the box from the Salmon.
Oh, Vi corrected me, not porn. So he says 30 bits per second dial-up connection sounds.
That's different than porn.
What did I read porn though?
It's just in your head, honey.
He said 30 bytes per second connection sounds to popular porn videos. What? I don't even know what that means.
Honey.
Anyways.
All right, look at this circuit right now. Does this look sound? Okay, so for anyone who's ever used Eagle or hasn't used Eagle, maybe I don't know, like this big. I'm gonna explain this from my non-technical, non-engineer point of view, because that might be more helpful to people, and then he's going to explain it as a circuit engineer who has 20 plus years of professional circuit design experience. So smart.
I'm at 30 now.
Cool. Jesus Christ.
Anyways,
old.
I know. Old. It hurts. Everything hurts all the time.
God.
No, grumpy.
She's grumpy and poopy.
All right, let's move forward.
Oh my God. Okay, so see this thing that says brain right here? It says brain. This rectangle here in the middle is the same chip that's on the Arduino. It's the Atmega 328 chip. And when you start making a board in Eagle, you start with the schematic, which is the white part. And everything that gets put into the schematic doesn't look like it's going to look in your actual board, which was weird for me when I first started designing boards, because I don't know, this is an abstraction of what the board will be.
It's like schematic started as how current flows, right?
Yeah. It's
like a plumbing diagram, left to right, top to bottom.
Yeah.
But now it's just hook shit up on blocks.
It's an abstract representation of what you're going to be doing. And basically what you want to make sure is that all of the stuff that you want in your board is dropped in here somewhere and is connected to your brain, and that the tags match up, so that if something says like bloop, it connects to bloop. And
right, so what do we got in here? What are our things? Why don't you take each thing that we put in here?
This is an op amp.
So that's the amplifier for the speaker, right?
Yes. This triangle is the op amp. This is the thing that's supposed to make the speaker loud, even though it's not. So
we gotta just figure it out.
It's bullshit. So, and then this thing right here on the end is the connector for the speaker. So this is going to be coming out the tween of the Salmon. I know that. And then there's a bunch of capacitors on here. I think there's like 4 for the actual circuit, and then 1 that's being used as a filter, which we haven't added yet. Nudge, nudge.
Have we not?
I don't think so.
I thought that was that.
Is it? Is there 5 capacitors?
Yeah, because we added R3 and C8.
I only see 4. Oh, that's
R3 and C8 are your low pass filter.
Okay. Okay, so everything's here. And then what's Whisper?
Whispers, that's your sound coming in.
Oh, that's from the...
That's the input to the amplifier. This sound out of the Atmega, the PCM signal.
Oh, that?
Right? Yeah.
Oh.
So zoom in on that. So
okay. So
that's on that channel.
So out of pin 13 is Whispers, and it goes into my op amp. So it gets pushed in from the left, and it goes into the triangle, and then it goes out the right through the connector. Okay. So it's like Whispers, op amp, and then connector. That makes
sure.
Yeah, that's how it works. And then up here at the top, there's these 3 4-pin connectors, J5, J4, and J3. These are for 3 separate strands of like NeoPixel LEDs that are going to go inside of the panties. And these are kind of like, they're like robot panties, so they're allowed to have LEDs inside of them.
Big.
They're big. They're big and boxy.
They're big girl panties.
Do you want to grab it? It's right there.
You want to show people the panties?
Fuck it. It looks like a fishtail, which is, I think, maybe appropriate or something. I'm probably going to pull the wings off. I don't know if you guys can see this, but this is panties with like a light diffuser in the front, and then in the back there's a bunch of mounting points for all the stuff I'm talking about, like the speaker and the lights and the board, the Salmon that I'm designing, and all these strips on the side light up. Although I'm probably going to pull these goofy wings off and just wear the fillet part. So yeah, this is the first concept of the what am I calling this? A beatbox?
Beatbox.
The beatbox that's gonna have the fish fillet inside of it. Where do you want to put it back? Is anyone saying anything interesting?
It just got up, so it's like a 30 or 40-second delay.
Wow. Damn.
Stealth panties.
Volvatron.
Volvatron.
Okay, and then this thing right here that says whisper. Wow, there's 2 whispers on here. I should probably change that. Well, there's whispers, and then there's whisper.
I thought no.
That one's for programming.
That's when you program.
I'll change it to something else.
Sure.
This is the programmer, the ISP programmer, and then the rest of the stuff, I don't know what the hell it is. Mark said I should have it. Oh, wait, no.
I can describe what everything's happening.
Yeah, go for it. Take over, mister.
All right, that connector here.
Yes, this SV1.
That is all of the signals you need to drive the SD card board. We went over to Fillet-O. They have a little SD card breakout, so it takes a micro SD.
Yes.
They do all... the SD cards run at 3 volts instead of 5 volts. So Fillet-O made a little board with a bunch of components on it that shifts everything down to 3 volts safely from your 5-volt system. So you can hook it into any Arduino, and that's the connector for it. So we just solder the Fillet-O board right on top of the fish board easily. So that's the connection.
How do I change the name of this?
It's cool. What?
Wait, can I change the name of this?
Yes.
Properties. What should I name the SD card thing? What would you name something that stores the memory of your dirty thoughts? Would you call that your
memory?
id?
Your id? I thought the id is not your memory. That's your drive of what you want.
That's like what your subconscious dirty raw.
Id is what your subconscious wants. Your ego is how to get the thing implemented and satisfy the id.
It's still your id. The id is what whispers.
Yeah, the id expresses desire. The ego figures out how to get the desire satisfied.
It's the id.
Right? Anyways.
Okay.
Sure. No, it's just an ID.
And then there's a dingle.
Dingle is your 16 megahertz clock that you need for Arduinos to run fastly. Over on the right is the D13 LED, which is on every Arduino. So that just lights up.
What should I name this?
I don't know.
Blinky?
Blinky? Sure.
Okay. White. My white blinky. All right, so that's.
Tony says you should call it a spank bank.
My.
Yeah.
For what?
To ID. Change it to a spank bank.
Tony
just himself.
You get points. Tony.
Come over for your spanking, Tony.
Well, spank bang. I love you. Wherever you are, hopefully packing and eating your veggies.
Yes.
Spank bang.
All right.
All right.
Go to other parts of the circuit. Let's talk about them.
Okay.
What other mysteries? What's that thing in the middle right there?
What one?
On the right middle.
The blackout?
No, right. Do you know which way right is?
No. Yes.
J2. What's J2 do?
Jesus.
Let's talk about it.
Oh, this.
Yeah.
Okay. This is the thing that communicates to the heart, the backpack, the brain that's running the whole peripheral show. That backpack thing, the concept sketch that I showed with the butt, the girl with the butt wearing the backpack. The heart-shaped board that is going to go inside of that backpack is the thing that's going to be responsible for controlling all the individual peripherals throughout her body, i.e. the crotch panty whisper box thing. But the heart needs to communicate to the fillet, the thing that's controlling the panties. And there's going to be a cable running back and forth between the two that transfers all the data and the whispers and everything. And that's what this connector is for. And it's a Molex connector.
No.
No? It says Molex.
It's a what?
Molex.
Well, Molex makes a header connect. It's a header pin.
It's a header pin.
But it's actually an FTDI cable pinout.
Okay, it's an FTDI cable.
So when we're debugging, if we had to, I could just plug an FTDI cable in.
Okay.
So that's why it's pinned out the way it's pinned out. Because FTBI. So Tony wins the internet today. Okay.
Yes, you do.
Move forward. Pick something else. We're almost done here.
I think that's everything. Lights.
Go on the left there. What's on the left?
I talked about the Whisper.
That's
Blackout.
the ISP programmer.
Yes.
Do you have any questions about those capacitors? You said, well, God, why so many capacitors?
Okay, so Mark, one of the things that he learned back when he was a programmer in Silicon Valley.
Board designer.
Board designer.
Programmers don't know how to design boards.
Mark was a board designer in Silicon Valley who sometimes programmed things in his whatever.
I did mostly hardware design. Now I program things.
He learned that you can't have too many bypass caps.
Yeah, you can't have too many.
So that's what.
Yeah, when you build something that has chips like a microcontroller or whatever, you have what are called bypass capacitors, and C4, C3, and C2 are what you see there. And what they are is they act like little micro fuel tanks for the chip you're running. And so pretty much any chip you put on a board, you should have one of those, so that when the chip suddenly draws a lot of current, like it turns an LED on or whatever, that it doesn't drain out the power available. Because sometimes a power supply that's a few inches away can take milliseconds or nanoseconds to respond to power levels, their power that's required for the chip, and it will starve the chip because the delay in it boosting the power that it needs or delivering what it needs. So these capacitors act like little micro fuel tanks, and they can, like nitro, like little nitro tanks in a car, like in a hot rod. They provide instantaneous power so the chip can run smoothly and get through that hot spot of turning an LED on or whatever. And then when the power supply catches up, it'll recharge those up. So you can't have too many little micro fuel tanks on your chip. It gets rid of a lot of dropouts, noise on your power supply line, because noise on your power supply line can cause a chip, like registers inside the chip doing calculations. You can cause a bit to flip because the power is browning out, and now you'll get the wrong answer on an equation, and a motor will swing in the wrong direction, or the chip will reset or whatever. So you add a few extra bypass caps. So a lot of people just put one, like a 1 microfarad. I put a 1, a 0.0, a 0.1, and a 0.01 to cover a bigger range of instantaneous needs for that reason. So
nobody wants their bits to flip or brown out.
So when we did motherboards, we had hundreds of 0.1 microfarad capacitors all over the board, like literally every half an inch.
That's excessive.
Yes.
But I guess it works.
But when you have a high-speed computer, you need to make sure that bad things don't happen to your customers, because they'll return your hardware and tell you your stuff sucks. Okay. So
you guys, wait, that's Discord. Where's OBS?
What is Sarah holding?
Oh, it's a shoehorn.
Oh, yeah.
This is a shoehorn from Tokyo, since I brought up Tokyo earlier. This is from Tokyo Discount.
That's a Japanese brand shoehorn.
This is a shoehorn from...
We found it at a Japanese dollar store in Sunnyvale, California.
No, we got this here.
Did you get that here?
Yes,
oh, at the Tokyo Discount.
Yeah.
That's right.
But it looked kind of like...
It looked wrong, so
I had to have it.
So you got it.
That's my friend. Okay, so I'm going to press this magical button. So whenever you design something in Eagle, it creates 2 files. Your schematic, which is the blueprints of what you're creating, and then there's the actual board layout, which is the thing that you're actually going to have made. And that's the thing that's going to end up looking like the cool cracker that you're going to get in the mail, that you're going to put little tiny pieces on. A foot fucker?
Yeah.
Noodle. Don't say that in front of Noodle. God. I'm going to get him asking
Tony's
what that
on a roll. Okay.
Jeez. Okay, so there's this button up here in the top that looks kind of like, what the fuck does that look like? It looks like a chip with something
with an op amp.
It's a logic gate on top of it.
Okay.
So it's innocuous, but this is the most important button because it's going to switch you over to a different land. And as you can see right here, there's sort of this salmon-y shape. It's kind of lopsided right now, but I'll tighten up my salmon when I'm getting close to shipping it out.
Everybody likes a tight salmon,
says Mark. Anyhow, so this is the outline of my board. It's on the dimensions layer. If I go up here, there's all these icons that I'll go through as we need them so that you are familiar with what we're clicking on. But there's this colorful one right up here, which are the layers of the board. This is hell right here. Don't worry about what all these mean. Mark will explain what they mean as it's necessary. The one that is important at the moment, if I click all of these off, say none, turn everything off, apply, nothing's there. I'm going to click on just the dimensions layer and then click apply, and the holes aren't in the right place. I got to move them, but this is the outline of my board. So this is where the board is actually going to be cut. This is the shape that you'll receive back from your board house. I'm going for a salmon aesthetic, so it's going to be something roughly this shape. If I turn everything on, all, click OK. What the hell are those?
You added.
Oh. Okay, I already kind of started laying these out, but when you first import all of your stuff into the schematic, and then switch over to your board file for the first time, all of the components that you laid out in your schematic have a different form, a different look, and they're just going to kind of be floating around here askew, and then you have to, it's your job to then decide where they're going to go on your board and which way they're going to be pointing. And this is the artsy part that is fun and that me and Mark enjoy ever so much. So I started putting the connectors, because there's like 500 of them, around the outside of my board. They're right angle headers. This is the chip. That big brain rectangle from the schematic is this thing right here. This is the speaker connector. I think this... That's the
FTDI.
That's the FTDI. This is the Spank Bank. J4, J3, and J5 are the LEDs. This is the Whisper ISP header, and then I have the trim pot, the capacitor, the op amp, and then a bunch of other like resistors and schmegma just sort of floating around. And there's the dingle. All right, let's do it, Mark. The very first thing that we're going to do is we're going to put a ground plane on both the top and the bottom of the board. Oh, which I should also point out, all these little yellow lines that you see going everywhere, these are showing you what needs to be connected to what according to your schematic. So if I pick up this capacitor and move it around, you can see that those yellow lines stay connected to the places that they need to be connected to. That's just to remind you that that stuff needs to be connected with a trace.
And that can help you place your parts in between the 2 points.
So you know where they
yeah, so you get better routing and stuff. So it's called a rat's nest, and you can see that it looks like a rat's nest.
So half of these are probably supposed to go to ground, and one of the tricks that you can do when you design a board is create a ground plane, which is like the negative space of your board, and you make that ground so that stuff that needs to be connected to ground is just sort of like, it's already there, it's already on the board. So if you make the board ground, then you don't have to route the ground to anything.
You know what rages me sometimes when I'm on like Facebook or Twitter? When people post their like Tindy, they post their board that they're selling, and it has no ground plane, and they're just traces hooking everything up, including the grounds. I like to go into a rage.
Don't do that to him.
Yeah.
Add a ground plane.
Then I'm like, that product sucks automatically because that person doesn't know how to do a ground plane. So
all of you Discord people, you use a ground plane, right? Right? Say yes so Mark can sleep tonight.
Yes. Always at it. Just do it. Top and bottom, please. Thank you. All right. All
right, kids.
Move on to the next. Yeah, no one's there. See any chat.
All right, ground plane. Show me. How do I do this?
Okay, so you're gonna draw a box. You want to do the variable shape, the one next to it.
Okay.
You're still gonna do a box. It's just easier to manipulate later. So start at 0, 0.
Jesus.
Yep. And then go into change, not dimension. Change your thing to top.
You want to make sure you're drawing.
And then change your width to Scheiße. It matters, and we can change it later. There's something that it affects in the board. I can't remember off the tip of my head. So just make it so we can see it on the screen. Make it 0.4. 4064. 0.4064. Yeah, that's a nice fat. And right click till you get the type of cursor that draws right angles. Click again. Yes. All right, go to your opposite corner. Go to the, zoom in on that top of the board there. And then put your mouse right over the top center. And then note the number 86.
Yeah.
So go over and then note the right-hand edge of your board. So move the mouse over to the right-hand edge of the board. No, zoom out a little bit. And then zoom in on the highest point of the roundiness of your board over there. Right here. Now, see how it comes out? What's the furthest direction? And look at the X number up here, the highest number you get when you trace the edge there.
53.
So 53, 54, go, you sure it's 53? So what was it, 86, 53?
86, 53.
53, 86. And then once you get that number, click once. 53, 86. Okay, now go down and go back to 0.
Wait, that's...
All right, we'll fix it in a minute. Okay, just go close it. Onto 0. 0, 0. 0, 0. No, you already had the... No, yes. There, 0, 0. Click. All right, that is the top ground plane.
Okay.
All right, so if you want to fix that, go and right-click the right-hand line and then say Properties, and then type in the actual number you wanted on the x-axis, so 54, 54. There. Now it's
better.
It's fine. It's gonna, if the box is outside your board outline, it's gonna clip off when they make the board anyway, so it can be oversized.
Okay, so this is gonna magically make half of these lines go away once I click the rat's nest button, which is this thing that looks kind of like birdseed right there.
So click it.
Click it. Ow. Wait, it didn't do it.
You did not close the shape of your board or your ground. Yeah, you have, since you have these coming outside your board,
yeah,
it thinks that you want to put components on the outside. So move those components to the inside of your board and see if this thing goes away. Okay, do it again. You have not a closed shape of your dimension, I think. That shouldn't do that.
Yeah.
Or no, not that.
Closed.
The dimension of the board, the white line.
Oh.
I think there's a gap somewhere.
Shouldn't be.
Why would it do that? Right-click it. Right-click the ground. Oh, you didn't call it ground yet.
Oh.
Do name the R2 icon. Click on it and type GND.
Okay.
There it is. Okay, so
Salmon.
now it knows it's a signal.
Salmon.
Or a ground plane, and it does the right thing. So you're going to do that step again on the blue layer, bottom.
Yes. So I'm going to go...
So you want ground planes on the top and bottom.
Okay, I'm going to do... Shh. All right, bottom. All right, I'm going to do that whole thing again, so I remember my numbers. I'm going to go straight up to... What was it? What was that? 50, 86.
6.
86.
You're on names. Go to bottom. You're on the names layer.
What? I totally clicked bottom. All right. 86. 50,
You're either a names or a value.
54.
I mean top or bottom.
What? What?
Nothing.
Drink. All right. Get another beer.
Okay, name it.
R2. That's this button right here. This is naming planes.
You can name things. Why are you... Just click it. You click it. You don't right-click property. You click a name and then click on the shape. There. GND. And then hit the...
Rat's nest. Click your bird seat. Bam.
There's two planes, two ground planes, top and bottom.
And there's significantly less yellow bullshit.
Yes.
So now I have to connect all the yellow bullshit. This is like...
Whatever. So zoom in on like pin 1 of that FTDI connector, and then zoom way in, and then you'll see right above the word J2, you see how it put little connectors onto that pin? Yeah. That's a ground pin, and it automatically connected all our ground pins, and like below that to the left, that's if there's nothing in the way of it or next to it, it'll do exactly that. So anything on your board that has a ground will be hooked up properly. So that's pretty cool.
So this is This is now a game of Snake.
Yeah, yes.
Let's start routing. Okay, where should I start? Should I do my op-amp first?
Okay, move those other parts where they need to be. The new parts you added.
Oh, this bullshit?
Yeah, and then kind of get some of your other stuff aligned up. Because it's hard. You don't want to reroute. Like, that crap is so congested. It's a joke. So...
okay.
Are you going to turn those 45, or are you just going to leave them?
Yeah, we'll go 45. So you can rotate. There's a rotate tool up here. Type in 45.
Right, so I'm going to throw out one of those other tips.
Yeah.
When you're routing a board, since like a board like this has a lot of space for routing, now that you enlarge the board. But one of the tricks is you can put your parts all over the board. When I'm talking about resistors and capacitors, you can put them all over the board anywhere you want. And I used to do it that way, but lately I've been, because I can route traces anywhere I want on the board, like a little switchboard, I start to line parts up in rows, like the C1, 2, 3, 4 on the right-hand side. And the reason for that is that when I am hand stuffing the board under a microscope, it's easier for you to find the parts you need when you're going down a row of parts and soldering them in one by one. Your assembly time is just gonna drop because it takes less effort. But if you're hunting for, let's say R2's buried somewhere in there, you're gonna hunt for about 30 seconds for R2, and then you're gonna do it for the next part, and then the next part, and then the next part, and you're gonna drive yourself nuts. So I do things in rows, a little bit orderly, and I just do that for my own ease, because you're routing a copper traces. You can put the traces anywhere you want. Once they're down and they're not shorting anything out, you're fine. So you can tweak that. Oh God. You people with your 45-degree angle parts. So dingle really needs to be rotated another 90 degrees and line up with those two pins. It probably doesn't matter a lot, but clock pins want to be short because you're dealing with a 16 megahertz signal. So you really don't want to stretch that across your board. And you kind of want them to be equal in length. Maybe it matters, maybe it doesn't, but the shortest path you can get to that. So
like that?
Don't get it too like back it off one more notch. Couple more notches. And then right there. That's perfect. That was perfect.
What should this be, my grid size be?
I lay out on a 0.1 millimeter. When I'm doing a board that's not all 45s like you're doing, I do it on a 1 millimeter. And then, no, that's for routing. So all my board placement is done in metric. So I do it on a 1 millimeter.
What is 1 mil?
Okay, so it's your board, since you're having some fine stuff to do it on a 0.1 millimeter. So fractions of a millimeter, 0.1. Okay, so I place all my parts on a millimeter, and then I route everything on a 6 mil, because that's what the board can do. The thing is, I was thinking about this the other day, is as long as, if your board house says they can do 6 mil spaces and traces, I'll route it at 6 mil because they say they can do it. But as long as you pick a number that's higher than that, you can do it in metric, you can do it in mils, you can do it in anything. So that's not a hard fast rule. It's the way I do it, because I want to maximize. If it's 6 mils, then I'm going to set the grid to 6 mils and maximize that. But if you're just starting out with this, you can do everything in metric. I don't remember what 6 mils is in millimeters. It's like 0.15. So you could just set it to 0.1 millimeter trace and space and trace, and then just route your board in metric or whatever. And some people are like, what did he just say?
That's me.
Mils are thousandths of an inch, right? And millimeters are metric, not thousandths of an inch. It's a metric. It's a thousandth of a meter, right?
Yeah.
So, or a millimeter is, but then 0.1 millimeters is even less than that. So,
anyhow.
But yeah, I use metric for most stuff now. But
I want to know what of this shit should I put on the back side of the board? Like, what of this?
Do you want to put things on the back side? If you want a clean looking board, you could put all your tiny stuff on the back and leave your brain on the front for looks.
What I want.
All right. So you go, the easy way, if you already have it placed, the easy way is move it go to move it, and then click the middle mouse button to mirror it. Send it to the back to move it. There, now it's on the back because it's blue. You see the blue?
Yeah.
And then put it where you want it. Now you'll see it's all mirrored and all that.
Cool. I'm banishing circuit boards to the nether. Now they're gone. Or components. I'm banishing components to the nether.
Pullis Squalus says, "It's okay, Sarah. I have an EM Phys exam tomorrow. And so I'm somewhat tired of electricity stuff too."
Aw. Good luck on your exam.
Yeah, good luck on your exam.
I hope you get a good night of sleep and rest.
Yes.
And have good dreams and then wake up and have an egg. Noodle says you should have
start off with a good protein in the morning and your test will go smashing. That and a monster or something.
What? No. Don't listen to him.
Stimulants are your friend.
No. Mark. Why is it flipping all my bits?
What do you mean? Because it's flipping and mirroring 90 degrees. So yeah. What it is?
I hate this.
I would once you get that done, I would re-rat's nest a little bit, and then like those 3 parts in a row you just did, they look like they could go to the other side, and now you're not constrained by a chip in the way. So you can do some cool stuff with that.
Which pieces?
Those 3 things right there.
Where do they need to go?
But everything, like just make sure things kind of line up. You get, oh, there you go.
Dingle.
Dingle.
Dingle. Okay, rat's
Dingle.
nest. Okay,
Right.
so everything's been banished to the nether. The back.
Right.
The butt. Don't touch the butt.
Okay. What are we doing here? So, okay, so both chips are on top? Is that what you're gonna do?
Mm-hmm.
Right. You should rename U1 to like
What?
make it louder or something like that.
Oh, this one?
Yeah.
How do I? All right.
Actor schematic. The other cool thing about circuit board design is there are standards for naming things. Like chips are usually start with the letter U, so U1, U2, U3. But that's great when you're doing a motherboard design. But when you're doing your own circuit board designs, I now name my chips for what they do. So I'll name the processor a CPU, and Sarah takes it to a whole nother level and names her amplifier Screm.
It's Scrim.
It screams.
It's Scrim.
She names her signals whispers, which is cool. So you can totally do that. It's your board.
Ah.
So
Okay. Okay. So let's do it. What should I do first?
See this? All this is all rat nesting over to those pins. So I would move those over to here. And now that you don't have a chip in the way, you can put them under the chip. You can line them up. What are they? What signals are they?
I don't know. Like here?
Sure. Where are those 805s?
I don't know.
I think
because they're from the board.
Are they?
Because they're from the anthropomorphize.
Oh, you did bigger chips. You should replace those with small chips. Unless you want to use my 805s. Which is fine.
No, I don't have to. But
and you can put a 603 across there just fine. You're just building one of these, and leave it alone. It's fine. Unless you want them all to be the same.
They should all be the same.
Okay, go back in your schematic.
Okay, I'm changing the size of the thing. And I go to change part, which is this one. Replace, yes?
Vigray sent you a direct message, so check it out after your stream. Thank you, Vigray.
I saw it pop up on my phone as something about DEF CON.
Tony wants to know, can you hide the ground plane layer while you're arranging components?
Yes.
There's a trick for that.
Mark says there's a trick.
Because it's well, you can just turn off those layers while you're arranging components. What are you doing?
I need to switch out the parts.
Okay, so you're going to do replace.
Yes, capacitor.
And then go into RLC. Are you use the seed or the?
I don't know. That's up to you. RLC. Capacitor.
Yeah, just use mine. They're more reliable.
Am I doing a 603?
All right. So say OK.
Yeah.
And then click each one of those. It did it. Don't worry about it. All right. So you didn't see anything happen, but it replaced the parts. So if you look at the board now, they should be small.
No.
Did it? Oh, maybe it errored. Go back. Those were the parts, right? Was it C2, 3, and 4? Oh, hit OK. You hit cancel. Why did you hit cancel?
I did?
Yes. Right, now do it. Try it again. Tiny boards with bright colors. Salmon color looks delicious.
Yes. I want a salmon board. I'm gonna color it with Sharpie because I can't get salmon solder mask.
I don't know why that's not doing.
Are these the right pieces? What the fuck? This is C9, and what is this?
Does it think they're already that? Oh.
C4, CR2, and no, these are different things.
Oh, that's why.
R4.
Okay.
R4, C9, and R2. Did I fuck up those parts?
2, 4, 9. It doesn't matter because that's what they should be. So go, but don't. So remember, your R's need to replace with R's.
Okay, so R2 and R9. Oh god.
R2 and R6.
R2 and R6. What are those?
Oh, zoom in. Oh yeah, that's right. You copied the reset thing. So go into those two. Okay. It was these three things. So go in and do replace on the capacitor and just do C9.
0603 C9.
Click C9.
Okay. And then R2.
Now, yeah, go and find the resistor, RLC resistor. It's down below that. Up. Yeah. 603.
Oh, 402? Yeah? Yeah?
If you want.
No. No. Okay. R4.
Click in the middle of it. Yeah, click in the middle of it. All right, now look at your board. Let's see what happened. Yes.
They're tiny.
They're tiny.
They have blue. Blue.
Oh, okay. Turn off the blue layer. That was for another project I did. So it's 3. No, it's not milling. It's like layer 300 or 200. No. It's called 3D Ref 1 and 2. Turn those off. Okay. There. That was for my Fusion. I had to import into Fusion. Anyways.
Okay.
All right, now re-rat's nest those and make sure they're what you want and have the spacing and all the fun goodness. Happy. All right, do you want to put them next to each other closer?
But your things.
And then figure out your stretchy. Yeah, there's 2 pins, 2 pins, 2 pins.
Yes, they're fine. They're happy there.
Wait. Oh, I see what's going on. You might put those near the connector. I would put those near the connector, not the chip. Those are for the FTDI connector. So put those in line with the FTDI. There you go. You can do the straight. I would do the straight in line at the top. No? You're going to do it that? All right.
Better?
Sure.
Whatever makes you happy.
No, I was up and down, not left and right.
Why?
On the other side of your SD card connector. Well, you're gonna have to run all these wires this way, the more wires you have overlapping each other, it's just going to be hard to route.
Where do I put this then? This
Well,
one.
you have 3 signals. 1, 2, 3. So I would put them 1, 2, 3.
But there's holes here.
Put them on the other side of the holes and then run the signals through in between the holes.
But there's holes.
You can run wires between the holes.
But this won't fit.
No, the resistor on the other side. Here. Put the resistor.
Oh, here. Huh.
Yeah. Move your chip down now that you have room.
Ah. Holes. Shut up. La 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 la. You go here, you go there.
Right, so get them rotated right.
Here.
Rotate that one.
Yeah.
Okay. And then you have the middle one needs to be 180. All right.
Are you happy now?
Yes, I am extremely satisfied.
Yes?
Anyways.
Are you better? Are you gonna get over it?
Eventually. All right.
Okay.
That's a prize-winning board. Okay, move that oscillator down in line with the pin there. Now give it enough space to get a via through the board.
It's fine. What? That is what?
A little more.
What?
We're gonna run a via and then run it to the top because you have to have, now you have a via, so that's too close. Back. But you can't see them on each side of the board. So there, that's nice. That's really nice.
Do you want to do it?
No, don't make me do your board.
Okay, now what? All right, I'm gonna start routing.
Okay, so are things? Look at what's crossing over other things and just make sure there's an opportunity to correct that. Where's your, I think blink is your LED?
Yes.
So where's your LED? It's going to probably be near the edge of the board and not the back.
These things R7 and R13 are huge again.
Okay, so let's go after that one.
R7 and R13. Where are you? R7 and R...
Is it part of your amp? Did we just pick the wrong parts or something?
R7, I don't see them. No.
To the left. It's probably your reset or reset circuit. R13, yes.
R13.
So do that one.
Bam. And R7. Do you see it? I don't see it. R7.
There, it's on your LED. So.
Bam. Okay.
Did you change it?
Yes, now they're small. Like the LED is not.
All right, go find LED. Oh, because you can't replace that part.
It's fine. It can be a big fat LED.
All right, move it to an edge or wherever you want it displayed because it's an indicator. So where do you want to put that? The top?
In the crotch.
You want to put it underneath the dot right there. You put it on the other side of that power connector.
Yeah, I want it in the crotch. Right.
And then de-rotate it.
Here. Yeah.
Okay.
45-degree rotation on the twinkler.
Okay.
There. It's like right.
Move it closer to the edge.
No, I like it there.
You like it? Okay. Now the resistor that goes with it, move that down near it. Oh, you're rotating. Right. And unrotate that. Unless you don't care.
Why?
Why are you doing things? All right. That's fine. That looks beautiful. Wow. Okay, hit the rat's nest button again. It'll redraw all your rats because you move stuff around.
Yay.
All right.
Yeah.
Yeah.
It's perfect.
You can route it. I mean, if this was a tighter board, it'd be a mess, but.
But I made it bigger because you were like, make it bigger.
That was looking scary. Do you want to make it smaller? Now that you're putting stuff, I didn't know you put stuff on the back side of the board. But that was a tight.
There wasn't enough room for the connectors.
Yeah, you didn't have so. Hooray! Okay.
Should I put things on the salmon? Should I put?
Put your holes in the right place before you forget. So.
Your holes need to go in the right place, Sarah.
Is that the mounting? Just give them a little bit of.
Can I map?
Are you gonna make them symmetrical or something?
Yeah, of course.
All right. So you should measure from the center. So find your center, right?
And do that way.
And then you're gonna add x and more in the x direction, the plus and minus, right?
Yes.
So, all right.
They can be wonky.
All right. Just don't forget. Well, that'd be like that forever.
You're just kind of like.
At some point, you'll export the DXF for this into Fusion and then design the part around it anyway, so it wouldn't matter. But yeah, with a drink.
Like
so.
Everything.
All right.
It's sort of wonky.
You're gonna.
No. No.
Yes.
Yeah.
Start routing. Okay, now we're gonna go into the 6 mil grid mode.
Okay.
So
what if I want to move?
All right, move. What's your? Yeah, get things optimized. What are those? Okay, so the bypass on your. Figure out what those are. That's like C9 or whatever.
Yeah.
Don't just put them where the rat's nest tell you, because for your power supply, it'll connect everywhere.
Okay.
So, but you put, let's say in the case of those 3 capacitors, right? C1, 2, and 3, they're specifically for bypassing the chip, and they need to be right next to the chip. So don't put them on the other side of the board, like across the board. You need to put them at the location of the chip. So go back to your schematic, find those capacitors in the upper left corner, sorry, in the schematic. They are C2, 3, and 4.
No, they were not.
Okay, C2, 3, and 4.
No,
those are them.
Those are. No.
What those are? We'll figure out what they are.
Oh, the C6, R3, and C8.
That's your. Well, what are they for?
I don't know.
Look in the schematic.
Fuck. Hang on. C6, R3, and C8 is C.
C6. Okay, that's part of your amplifier.
So it's
right?
Amp things.
So put everything near the amplifier.
Okay.
Which it is.
Yes.
Okay.
Why aren't they connected to the amplifier?
Because they feed the amplifier, and eventually one of those things connects to the amp, because that's the adjusting resistor. So it comes out of the chip, it goes through this, goes down here, and comes back. So this is your last chance to optimize that.
Why is this not connected to anything?
That's a good question. It probably didn't get connected in the schematic. Sometimes things don't get completely connected. R1. I think that's the output of your. Yeah, down here.
Yeah.
Oh, that's because Seed Studio, thanks to Seed Studio, their library overlaps. Their pins aren't on a 0.1-inch center. So they so see if you can get those connected. No, don't. No, they're overlapping. Move the part down.
I did it.
Oh, you did it. Jesus. Anyways. So that's a 10 ohm to ground with that capacitor off the audio signal. That's a good location for it. That'll probably work fine. So now your input section, right? It comes out of the chip. It comes here. It goes down. So do you want to move that so that it's in between ear and ear, or is that? It's a small board. It's probably fine. Leave it alone. Yeah, it'll be fine. What's C8 do? It's not connected to anything. C8.
Where is that?
Down here. What does that do? Find out what it does. Oh, it is connected. It's zigzaggy. Okay. Oh, and it goes to ground. Oh, that's the filter. Okay.
Don't do it. Don't.
R13. That's your input pull up.
Where
move R13 to the next to the either over here or down here, but it should be closer to one of those other parts that you have.
What? It's connected to like 5 different things right now. Like
that's the power supply. The one that's by itself.
Yes.
This over here.
Yeah. That
is the one that matters. So you either want it near that or where it came out of the chip, which is down here. Your choice. You could rotate the choice chip 180, since you have things crossing over here and then crossing over there. So slap that down for a minute, and then rotate your chip 90 degrees at a time and see if the rat's nest looks better or worse. That's one more. That's half of it. Click again.
They are all bad.
Right, so it doesn't matter what you do. You got plenty of room to route. So sometimes you can get a better lineup or shorter traces, but in this case, you have things going everywhere. It doesn't matter.
No.
Why did you do that?
It's being a...
You clicked an icon without.
Shh.
Don't worry about it. You have so much room. We're just gonna route it.
Okay. Should I want to center things and make sure that they're like.
All right. Find the center of your board and then put the chip on the center. So look at the apex of your here or here and figure out what is the true middle of your board. That's probably the best one to use.
Which is 27.
27?
Yeah.
All right, put your chip at 27.
That's a 27.
So it's already at 27.
Mm. What's everyone talking about?
God, this blew up.
What's everybody talking about out there? 27. Everything's on 27. No! What's everyone talking about?
Amir wants to know, do you have like 1 gigabits per second bandwidth? What the hell is this stream quality?
What? Is it bad?
Is it bad or good? Because usually it's bad. It looks really good to me. And I'm getting it off YouTube on my phone, so I don't know. Maybe YouTube like stopped punishing me.
Oh man. I don't even know what that means. I hope it's
Gotta
good.
go for 10 gigabits per second. Not in America.
Not in our
Gotta move to South Korea if you want that.
Okay. I want these to be. What is the X on these? 45?
What do you mean? You want to rotate it more, or you're just okay? I don't know.
I'm trying to get them on the same thing.
Minneapolis has 10 gigabits per second. Wow. Not Las Vegas.
Yeah, no kidding.
I think we're at 60 megabits here in Las Vegas. So gigabits is kind of like fantasy, I think, for us.
Yes.
And 60 megabits is the high-priced cable connection out here in Nevada. I think the low-priced one is 10 megabits per second.
It's all crap. Everything is crap.
Yeah. But the thing is, all my streaming movies play just fine at 60. So,
where should I start? Should I do my op-amp first? Oh god, that's the wrong way.
What are you doing?
I don't know.
Right. Are you hooking up?
Yes.
All right, you in the 6 mil. You need to switch your grid. 6 mil. Go to mils first.
All right, we're changing the size.
Type 6.
6. Changing size.
Change that to 1
1
mil.
1 mil.
All right. So go ahead and hook that op-amp up just for...
It seems like this needs to be rotated. This one.
But it's hooked to the other one in that way, so you're gonna... Yeah, I wouldn't do that.
All right, fine. Okay.
So click your route. Click it. Right click so that it comes straight off the chip. Find the mode that where it doesn't. So move the mouse Okay, right click, there. That's the one you want. No, hook that up to the. You're gonna have to do pop a via, right? You in six? Oh, you're in 16 mil, right? You did the grid at 6 mil, but select 6 on the menu. There you go.
That's too thin.
That's what the board house does.
What? That's like super thin. That's like
6 mil traces will do 2 amps of current.
That's super thin.
Believe it or not. Okay, make it 10 or 16, whatever fits. Knock yourself out. Okay.
I want fat.
Okay, and then change your drill now that you're doing it. Okay, you already have a drill of 12.
Okay.
Which I don't know how you got that. I don't get that. So no. Click next to the pad. That's unnecessary.
What?
I put the via closer to the pad. You don't have to, but that's me.
It's
all right,
fine. It's fine.
Okay. That's right. It's not my fault.
Okay, we had one pin is routed.
The customer gets what they want.
How long have we been doing this
Tony,
now?
is there an auto router for Eagle? The auto router costs an extra $400 or $500, but yes, there is one for Eagle. So in the free version, I believe it's not included. It might be. I don't know. Sarah's using the free version of Eagle. I use the paid version of Eagle, so I can do larger boards. And the auto router costs more. And auto routers suck. Do not use auto routers. If I see somebody using an auto router, I will punch them. They never do the right thing, and you spend all your time fixing it. So route your own damn boards or get out of the business. All right.
Here I come. All right, next pin. Only a million more pins. Wait, where is this going?
See how they highlight over there on the chip?
Yeah.
Those are your VCC.
Yeah.
It's got to go over there anyways. Where's it got to go? You can either go up or you can go down. It's up to you. Yeah.
On the top?
So your VCC connects to everything on the board practically.
Yes.
Right? So you're going to have to daisy chain this. So I would probably go to here and then daisy chain this all the way around to the Whisper connector. So you can, yes. There you go. Straight up. Perfect. That's going to be fun. And then pop it before you do a via, pop it to the bottom. Because it's on the bottom, the blue. Nope. No, that's a via. The connector is a via, so just go to the blue. There you go. Start at the blue there. Perfect.
So this is Snake now. I'm playing an epic game of Snake. No. Now.
You can go right to that pin above you. And then route that pin above that up even more. Go across carefully, and then go back. Go left a little bit. Go up a little bit. Click. Now finish the route. Okay.
I starved the hole.
What? I wouldn't worry about that.
Okay.
That's good for that. Okay, so that goes down. So you're gonna pop a via down to the bottom and go straight down. No, go the other way. There you go. So go there, pop a via, and go straight down. And then,
It's just like playing Snake. Snack. This is epic Snack.
Right. That can come straight off the pin if you want, since it's going to go that part. So you're going to pop the via.
Okay.
Do it for the second one. Same thing. Make it symmetrical.
What,
all right.
Is that gonna bother you?
It does, but like I love you, so it's not like really Doesn't mean anything.
I love you, so it doesn't mean anything.
It's adorable. It's endearing.
Mark likes to make fun of my board designs. Like when I made
Taylor says, ah!
Taylor, ah!
Vigrate calls this part, don't cross the streams. Yes, Vigrate.
Don't
cross the streams.
This is epic snack.
Exactly.
Snake crossing. When I made the noodle brain board with all the, like, when I did it, I was using, like, this mode to route all my strings, and I was, wait.
Oh, that reminds me, Noodle told me the other day. Oh, God.
Like this to connect everything.
She did a whole board like that once, and it was epically cool. You could do this board like that.
I routed all my strings.
Do you want worms in your salmon?
Like this.
Is it a freshwater?
Should I put worms in my salmon? Mark wants to know.
I might walk away if you're going to do that.
You're going to love it. Should I rip up everything I just did? No.
Oh my God. Do that on your next board.
Oh, on the heart? I'll have heartworms instead.
On the heart, you should do jagged, sharp. Anyways.
Why? Why? Because you're jaded and
that's
you
my heart.
Don't believe what? You don't believe in a thing called love?
Well, that used to be my heart. I was a broken heart, jagged. I used to hate everything. Okay.
You still do.
I found you.
You still hate everything.
And I hate everything except for you.
Mark believes in a thing called...
I stopped hating. I just don't care anymore. And I feel so much better. So connect that right onto that sucker. Perfect. All right. Whoa! You still have your squirrely... I forgot that was there. That's art. Look, it's like little eyes and a mouth. It's like,
Should I leave it?
No, that your board probably won't work anymore.
Wait, these two things cross now.
Yeah, you need the things. All right. So yeah, route that on the top then. Well, you're gonna need routing on the top. I would get past that bottom section on the top, and then so move to here, pop a via, and then finish, or vice versa. You might run that between all those parts. Those three parts?
Yeah.
You have enough room to run a trace between them. I would probably do that.
No.
You might have to line those parts up to pull that off.
Like this?
No, you can't. The blue layer already has stuff on it. Oh, top layer. Okay. No. Between the two pads.
There.
No, you have to. No.
Wait, what are you talking about?
Cry.
Wait, between the strings? I don't want to do that. That's dangerous.
Zoom in on those three components right there.
It's dangerous.
All right.
Just put it between.
You can run.
No.
If you get these aligned on the same Y, you can run a trace right down the middle of that.
But I liked it the way.
No, but you have 6 wires going up and down. You're crossing 2 layers worth of wires. So.
Like that?
Yes.
But
oh, that's the top. No, you have to do that on the bottom. Try that again. Unglued.
Happy?
Yeah.
Are you actually happy?
Oh, okay. Now you have to pop left of that. Okay, yeah, line those up. You may have to type the values in to get them to be.
Okay.
Go to the left.
It's like not...
Yeah, so you're going to need to run that. Okay, your other alternate is you can run it on the top layer here. Because
there's
nothing else. No, those are going to be on the bottom and run through these pins. So you can run this on the top over. Or just make more vias. It doesn't matter. Welcome to my world.
I'm way
and
less...
run it around the back side of the connector. So keep going. No. You could do that too. And then the back side of the other connector. There you go. Well, you don't have to get that far with it. I think you had it fine before. So, yeah, drop it in. No, go straight into it. There. And then you can clean up that trace. That is fine. You don't hit anything. There. Look at you.
But it's too close.
It looks close, but as long as it passes DRC, you're fine.
But it doesn't make me feel warm and soft.
Oh, you're like me now. You can move the traces. You don't have to reroute it. That's like, wow. Like, I'm gonna walk around this thing.
It has to be safe. See, it's safe.
You're like me in Zelda when I see a monster in a field and I walk around the whole map because that monster might see me from like 2 miles away.
Safe.
That's that.
Safe. It's
fine.
Safe.
Have at it.
A lot of pop.
All right, let's keep routing here.
Okay, next pin. Let's just do this one.
James, the Orb 2 Masteros, is confused about what the meaning of the word screm means. He says you should call the chip scream instead of screm. But screm is what birds do, so they don't know how to spell. That's why it's screm and not scream. It means the same thing.
If J2
James,
is spanking
so,
in his brain, should scream instead of screm?
No. You can make it bran.
It's screm. It's that's
and spank bank with ease.
Spank bank.
Spunk bank.
Spunk bang. That's like a sperm bang.
Yeah.
Spunk bang.
In England, it's called a spunk bang.
No, screm is how birds.
They scram.
They scram.
Like, ah! Ah! Okay.
This goes to that.
You know what? Before you do that one, those up and down signals, you should get those out of the way since they're all parallel to each other. Start on the blue layer for that one. There, straight in. There you go. Next one, straight in. Straight in. Perfect. Now do the next 3 that are on the SD card. No, not those. The SD card ones. Yes. Just do those. Do them on the top. I wouldn't do that. Don't enter a pin that way. You're creating
What?
That's good.
Don't enter.
No, when you create really V shapes where 2 traces come together like that, you're the acids and the etching can get trapped in there and keep etching a groove out like a wedge. And literally make the connection break over time. So they tell you not to do hard angles like that on PC boards. You could have just routed that on the blue layer. Oh, you still gotta pop it through, so it doesn't matter. So do what you were doing. I'm confusing. Do whatever you want. Sure.
But that's ugly.
I know. So you're becoming me.
I don't want that.
What's the poetry of the board?
That's why I don't sleep at night.
You can start on the blue layer and then pop it up right next to the pin. Yeah? Because there's nothing on the blue layer there. Is that okay?
No.
So route, start on the blue. You could route that around, up and around the pin like that too. Totally go around it now. Do a couple of 45s. Follow that white, yeah. Perfect.
I made a bad.
And then you can push those together so there's no blue space between them. You're gonna have to adjust your 45. I think they're 2 close. No, they're 4. Now slide that whole diagonal all the way up. No. Didn't know about it. Just put it. There you go. All right. All right, one of the other things I just noticed is your program. So your SD card thing shares the connector with the programmer, the wires. So you can either put the 2 connectors near each other, or you're gonna have more shit to route. It's up to you. Does that make sense? Yeah. But you'd have to move your connectors around, so maybe that's not a good idea. You kind of can.
Wait, what did you say?
The SD card uses SCK, MISO, and MOSI.
Yes.
So does your programming header. And that's on the other end of the board. So if you wanted to route things into an area close to each other, you would put those 2 connectors near each other.
I want this to be on the back, so is it the wrong way?
Yes. It is. So you need to flip that connector. Unconnect the... Just remove the traces that connect to it. And then the one to the left of VCC, just part of it. Just the upper part. That's fine. Okay, click that. All right. Now, click the middle button. Line it back up. Is that what it was? Mm-hmm. Drop it. Oh, you're gonna hit that.
It doesn't say the right.
Oh, you're in mils now. You have to put the grid back to millimeters.
Okay.
That's fine. Oh, things line up better now. There's 4 wires. You can run them together all the way to the other side of the chip. Oh, where they go? Yeah.
Ready? Okay. No more backwards progressing.
All right, keep doing what you're doing. You're kind of doing it right, so just...
I know how to do this.
Let it happen.
I like your expert cheesing opinion, honey. Where should I do this one?
I'd almost do as much as I could on top and then use the bottom for... That's too close to the chip. Like, you should go... You kind of had most of it right. Look at the rat's nest. All right, continue that one. Just kind of give yourself some distance from the chip. So go straight across a little more. Sorry. Go back to the left a little bit. Now, go to the right just a little. Okay, now make a 45. And then head toward the chip and connect it. Yeah, like that. Yeah, it's beautiful.
It's how you do it?
I'm like tears coming to my eyes. All right, do those on the bottom.
Okay.
And then run, I'd run those 4 together as like one bundle and run it. Well, I don't know if they all go to the bottom. They look like they might. But yeah, run that first one as kind of an anchor. So run it there, run it off the edge. There you go. Pop it. And then aha. You may have to reposition that little trace thing so that you can run that on the bottom and then pop it to the top. No, don't do that. That's evil.
Why?
You're just routing shit over and under each other.
Isn't that what you're supposed to do?
You can, but it's not a beautiful board anymore.
It will never be a beautiful board.
All right.
You can't see the traces. Solder mask goes over them. You can't see them. You could literally just... I could just draw straight lines from all the parts and connect them. Like that fritzing shit. It's just like fucking hay straw.
God, you said fritzing.
There's nothing wrong
whatever,
with it.
Honey.
What else would I do?
Okay.
There's nothing else to do.
That trace you just routed before it?
Yes.
You would move it.
No, it's the same no matter what.
You darted it to the right. You'd get it out of the way. So reroute that one. So hit Control-Z a couple more times.
But it's beautiful. You're like tears coming out of your eyes, and then...
One more. Okay. Now, start with the middle pins first, then. So do the second one that you did.
Fuck this one?
Yes. Where that would go, start on the blue layer. Goes down near the pin. Now pop. Yeah, do a little bit of tweaking. There you go. All right. Now do the other one that's near the middle. Oh, God. Okay, that's
fixing it.
All right.
No.
Why?
I'm fixing it.
All right.
Quit it.
That's nice.
Quit. Quit it. Where?
What does the chat say?
You guys are awful.
Need to put in strength for What? That's crazy talk. We don't share pins on connectors as free videos. That is not. That is wrong. Vigray says he's having fun watching Mark's soul crush as you mentioned straight line tracing.
Ha!
Thank you, Vigray.
See?
Thank you for feeling my pain. You understand.
You know he's enjoying your suffering. That's what he's saying.
Yeah, but he understands, and that makes me happy.
No, no one understands, Mark.
I don't care if people enjoy my suffering. It's that they understand my suffering enough to enjoy it.
I starved something.
All right, so you're going to just make that bevel smaller so that the flood can get through there.
What?
Yeah.
What?
See this bevel? You
Yes.
can bring it in here and bring it up here to allow the flood to come through. Just can't, See? All right. Royd says if you make the traces straight, the electrons go too fast and they fall off. That's just science. You are 100% correct.
No.
So curved traces give something for the electrons to do, like a little amusement park. And they'll stay on the board because they love amusement parks.
They're like the love handles of board design. They give you something to hold on to, so you don't just grind your hip bones against the other person's hip bones.
Yeah, because that's fun for about the first minute only.
Sure. What do we... Oh, go on.
All right, we're talking about science.
Oh, God.
What do you do? Okay. All right, now... focus on...
What the fuck?
You can probably route that. So it's going to cross over those other three. Do you see how it crosses? So that's going to be fun when you get to the end point on this. So you're going to have to kind of... Making progress. You should do that third one up there.
Right.
Is that pretty fun?
No.
Something's not pretty fun.
Quit.
Just delete that segment, not the via, and then reroute.
Ah.
All right. Just keep going. It'll be fine.
I know how to do. You just don't like it.
I know. It has to be perfect.
No. No.
Must
No.
be perfect.
No.
Ah.
No.
No. Wrong. Red versus blue. Are you playing that? Did you see me that time? Alright.
Why is that?
What are those?
I don't know. Capacitors.
Oh, you can flip the C3. There you go.
Shh.
That's the bypass for your chip. Why is it all the way over there?
I don't know, because they're bad.
They need to be. It probably wouldn't hurt anything, but move them as a group. You can pre-rotate them. Just move them as a group closer to the chip.
No. Are you ready to go to lunch with my mom tomorrow, Mark?
Oh, shit.
Are you ready for it? Does that need to go there?
That's probably a good location. Sure.
Is that close enough for you?
Yes.
Okay. Are you ready to see my mom?
Yes, I love your mom.
Is she's gonna hold you.
She's a good person.
She's gonna hold you.
She just takes a little bit of getting used to.
She's gonna hold you.
You can go straight into the part. Oh, that's right. It's blue. Sorry, I didn't see that. Go over it. Sorry. My bad.
I don't know. Wait, what?
So right there. There you go. And then you get it.
Shh. Those aren't straight.
Not straight? No.
They're not on the same pizza.
Yeah.
No.
Oh, the parts.
They're not on the same pizza.
No.
Not really.
You can type in their X and Y by hand if you want them to be exact. Alright, so see where on C4 where it goes into the chip, you need to get that there. You're gonna have to go. So pop to the top. And then wire those up.
Fuck.
Wire them on next to it. The rats went away for it? No. Click on. See, there's a little faint wire right there because it goes around. Just hit escape. Don't do that one. Click on the pin itself. Right click. There. Now go. You can go on the inside, yeah, and then around. All right, and then go across the chip. You see that one? Perfect. That's probably good enough for what it's for. Connect your. Yes.
Is that too close?
Yes, by only a fraction. That's good. All right, so you're gonna need to get the second one in there next to it, and then you'll have to scooch the VCC around that. So just route it first, and then scooch the VCC around it to clear it. So do the second pin on that.
I'm gonna do something weird.
I would do exactly what you did on the other one. It's kind of critical. It's the clock. Don't fuck with the clock. Here you go. Perfect. Now take your. Use the move tool and get the VCC away from that a little bit, not a lot. It's fine. No, that's perfect.
But it's touching.
What's touching?
The green is touching the VCC.
Move the VCC, not the green. The green needs to be where it's at. That's what I'm trying to tell you. One more clip. Do the other side. No. Yes. If that doesn't DRC, then scooch it just a tad, but I think you're fine. All right. All right. Connect that other connector on the left side. The VCC.
What?
From your capacitor to that connector. Just grab that.
On the blue?
Yeah.
1 ton of mayo. Doot, doot, doo, 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 doo. 1 ton of mayo. Why is that part hanging
That's
out?
good what you did.
Oh, I did that.
Yes, you did.
But why does it say SCK?
Because remember?
Oh.
So just get it.
Oh. Shh. I know what I'm doing. I'm good at this.
All right, Roy Good says, open question for anyone to be able to drive a lot of tiny motors that can go forward and backwards. Do you just use a whole bunch of motor driver chips or other options? Tony says, one motor driver chip and a bunch of relays, but only can control motor. I would not use relays for motors because for higher power motors, you can actually fuse the relay connectors together. The first robot I ever built was relays, and I had problems with the relays sticking because the arcing would actually weld the relay contacts together. You should use semiconductors in this modern age. But there are H-bridge drivers or motor controllers. I think you can build. Sarah built an H-bridge driver in school out of what? Transistors?
Yes.
So you can do that. The motor controllers are nice because they are H-bridges with a little bit of control circuitry to keep you from shorting out the H-bridge, because if you actuate your H-bridge in the wrong logic configuration, you can literally short the plus and minus of your power supply together and make the chip smoke. So a lot of modern motor controllers have circuitry in there to prevent you, the user, from doing that to your chip.
Fillet-O sells motor drivers.
Yeah, Fillet-O has motor drivers. There are just motor driver chips out there that are good. So it depends on what you're doing. They're really small motors. Yeah, if you want them to go forward and back, you definitely need an H-bridge of some sort. I don't know what low power H-bridges there are out there. I think I looked once and I didn't find any. They all want to do like 1 or 2 amps at minimum. But there might be something. Or you just look up H-bridge in Google and build, get some little FET transistors, some cheap FETs, and build your own. You might try that as an experiment, just for fun. But yeah, I don't think there's any easy method for that, for lots of little motors that want to go both directions. That's kind of that would be kind of a tough one, or it's just going to cost a little bit of money. So.
Look.
Cheeky.
But there's a little hand.
A solid state relay is a FET, right, droid. So yes, you can use. I wouldn't call them that. I would just use a FET or a transistor. When a modern transistor has a good low on resistance, they act better than switches. But yeah, look up H-bridge on Google and see what you come up with. There's probably a few simple circuits out there.
Okay, now what? Mark got really quiet and now I'm scared.
I'm reading the comments.
Oh.
Roy Dredd said he's seen motor driver chips are handy. You've seen some with dual H-bridge flyback diodes. Yeah, that's it. Yeah, you find one that has 2 or more channels in it. That's a good option for a few bucks for a chip. So, Handsome Rob is late. He wants to know what's going on. We're routing a circuit board in Handsome Rob. Or Sarah is routing a circuit board. I'm just sitting here being a pain in the butt.
He's making sure I do it pretty.
I'm imparting the knowledge that I know in the best way that I know how.
I don't know how to get over there.
You can go around the top, maybe on the top layer. Into the. You see that? Yeah, don't go through the middle layer. So start on the blue layer, go kind of as far as you think you need to go, and then pop to the top.
Where?
So go over. Well, don't hit that blue. So go, then guide it up again, click, and then pop to the top. There you go, and then you're at it. Okay, there we go. Yeah, stick right at, yeah, there you go, right. Just hug that thing.
Hug it.
There you go, and then drop it.
Mm.
Ooh, that's starting to look pretty.
Ooh, it looks like a circuit board because I put pieces next to each other. Ooh, I starved that. It's okay. It's okay. Ooh. Ooh. Baby, let's get it on.
James says that he's imagining Sarah's mom, and she says, "What have you two been working on lately, dears?" And the two of you just blush.
That has never happened.
That's never gonna happen.
That's never, ever gonna happen. We don't blush.
No, it's just like, I don't care. It's just like, Mickey, we made a thing that vibrates and gives us both orgasms.
But that's not what
and
we're
she'll
making.
be like, what?
That's not. We haven't done that. Even the lick thing.
No, but I would. Like nothing would make her blush or me blush.
But even when we were making like the lick,
yeah,
and I made the strap on and all this crazy
that's
stuff we've
true.
done in the past, she's just like doesn't.
She's like,
She's like, that's nice.
I don't
kids.
know what that is.
That's
yeah.
nice, children. No, I'm pretty...
James in his mind, your mom is 80 and British.
No.
No British accent. That would be charming.
That would be charming. My mom is like a cross between Cruella de Vil and Peg Bundy.
Yeah.
That's always the go-to analog for my mom.
That's definitely a movie right there.
No, I think I've told her about the She-Bone project, and she's just kind of like,
she doesn't get it.
That's interesting. Like, she supports it. She just, that can't be. What the fuck am I thinking?
Are you running out of...
I'm doing dumb things. So.
You can route that on the top around that via, or move that via back on the top. Does that make sense?
I can do this.
So you can take this via and shorten it up to here, and then run that pop it up. Well, you can route the blue under the red and then pop it here and connect it too. You can totally do that right now. So just extend that blue a little more. You can just move traces. You don't have to like delete them.
Okay. Cool. I made an X. I made 2 X's.
That means it's not connected. Where the traces come together. Are you cleared it up? What are you doing?
I wanted to get rid of that.
Alright, do whatever.
Why don't you like me?
I love you. I just wanted to.
Alright.
Just slide that upward. There you go. Keep the 45 on it. Alright. Now you can use the bendy tool to straighten that out.
Yes.
Oh, you're doing it. Okay.
Yes. Oh, perfect.
Right, hit escape.
Like that?
No. This is weird. Hit the rats. Alright. Now pop that to the top.
Noodle says no. Why is my blackout fuse there?
That's just where you put it.
Okay.
So now you need to route that to the top.
That's just where the raptor put it. Is that supposed to be on that layer? Yes.
Yes. Figure out where it goes. You get to go around the chip. Yeah, just go kind of through. Yeah, keep going.
Ah. Shut up.
Zoom way the fucker.
You do this. I've seen you do this.
It's because I'm blind.
I have new glasses on. Aren't they nice?
James says this thing needs totally curvy traces.
Damn it. Should I tear it all up and restart?
No.
Because
James.
I can totally do
the
that.
next board.
I agree.
I promise. The next board can be planned.
It'll be like my salmon has worms.
Once you have those laid, you can curve them.
Salmon.
Did you know that?
Salmon worms.
Just you.
It's not as fun. It's not.
I know it's not as fun, but
salmon worms.
Yeah, let's just add a bunch of inductors to this board and see what happens at high speed.
Yes, it's like you want to slow them down. Otherwise, if they go straight from thing to thing, then the electrons.
I don't know if it's slowing. It's keeping them getting so bored that they leave. You just give them a fun little thing to do.
You don't want them to leave your party board. Get it?
That's
party board.
It's a party board. There's a party downstairs.
I just leave the party board.
Party board.
I need more cookies. Make me cookies.
Tomorrow.
Really? Whisper.
Real lady bone PCBs have curves.
See?
Lady bone.
See? This is the Fillet-O. We'll excuse it.
I kind of want this board to get done because you're not going to get in my seed cart.
You're not going to get in my seed cart either. Okay.
Yeah, I'm rushing her to get this board done because in the next couple of days, I have 4 circuit boards ready to go to send off to Seed Studio, and hers can get in there and she can piggyback the shipping and the $5 board cost if she gets in. Otherwise, she's going to pay her own shipping and all that crap. So you get in on that train when it leaves the station.
What the fuck is this?
There's a top and bottom on each of those. Remember? That's a straddle. Oh, you need to move that connector to the edge, otherwise you'll never get the pins. Well, I guess the programming pins would fit on that. But I would totally bring that to the edge. So I would unroute that real quick. Remember the pins straddle the board?
Yeah.
That's inside the board enough that pinching it on the edge is going to be, you may not make contact when you try to program it.
Oh god.
So I would kind of scoot that and angle it out.
Where's my constrained properties? There, is that enough?
I would angle it with the edge of the board. Or are you going to leave it like that? Is that fine? Okay. Yeah, that's better. It'll work. We'll make it work. It won't. It's not the end of the world.
Are you sure?
Yeah, because we have the long programmer pin thing, remember?
Yes, I remember.
The only other thing is if I make that clip-on thing that I'm thinking about making, that other connector's in the way. So can you give me a little more left and right room on that? That's one way to do it.
There, look what you made me do.
Look at you.
There's no fixing this. It's ruined forever. Literally ruined forever. Is that 45? We'll never know.
Ish. You need the 45 too.
Fuck it, it's good enough.
Yeah.
No one will know.
It really doesn't matter.
Like literally, we can draw straight lines.
If you can do curved lines, the PC board doesn't care what your lines look like. So
that's why I route in curves, and I have to start over and make them curved. Yeah.
You tomorrow can live stream that. Oh, we're busy tomorrow. So,
yes.
Yeah.
I need to do the heartboard after this.
Yeah.
The pulse pack.
Yes.
The salmon, the
So you should
Fillet-O, and the
do-
pulse pack.
Yeah, your heart should be a bunch of like threads, curly threads. That would be the theme.
I have heartworms in my
Heartworms.
yes
You got it from the salmon.
from the salmon.
The salmon and the worms escaped the salmon.
I have crotch worms.
True story. A friend of so we like sushi, like salmon. I love salmon sushi, and a friend of ours refused to eat the salmon sushi whenever we went to sushi. He didn't eat tuna, and we're like, "Why don't you like the salmon?" And he goes, "Well, a lot of salmon has been in a freshwater situation. It went upstream or whatever, even if it's from the ocean. But that salmon went to fresh water, and they pick up parasites in freshwater streams in the form of worms and stuff. And the thing is, if you eat raw salmon at a sushi place, and there's a parasite in it, you can potentially get it in your system and get worms. So after that, I don't eat raw salmon anymore. Like cured salmon's fine; it killed the worms.
What about this connector?
But don't eat raw salmon.
Can I connect these together? Whatever they are.
Yes.
Do I do it at the nipple?
That's
or
fine.
over here?
Do it at the do it there.
Don't eat my raw salmon.
Don't
Mark.
eat raw salmon. Make sure it's cooked or pickled.
How am I gonna add my fat stripes, guys? Like I need to add those salmon stripes.
On this?
Yeah.
Ah.
Yeah, it's gotta happen.
I would do it all in silk screen, because if you start screwing with the etch on that board, you're gonna run down.
I need at least something.
You almost should have established that before you wrap it. No, I guess it doesn't matter now.
I need to add these stripes.
I would do a red board with white silk.
Fine.
If it were me.
Fine. Red salmon. Call it the red.
It's deep red.
If your salmon turns red, it's being actuated too frequently.
Too much oxygen.
Too much oxygen into your salmon is happening. Okay.
James says we have heartworms, and his dog has pills for this. I don't know if it's heartworms.
Yes.
Is it heartworms?
Yes. Don't get worms in your
So you just get the dog pills and you'll be fine.
But what if I want to add worms to my salmon after everything's been 45 degrees?
Vidre says we're gonna make bluefin tuna go extinct. So all together, let's all go to sushi and work on that.
We have a sushi. I told everyone about this sushi place. We have a all-you-can-drink sake, all-you-can-drink sushi place that everyone needs to come have sushi with us at, so that we can kill off all the fish on our planet, eating them. So it has to be a thing, right?
Yes. Let's not leave any fish to the next generation.
No, screw them. Okay, where does this go? This yellow line looks like it disappears at J2. This was never finished.
It's an unfinished VCC.
Cool.
So you can connect it right down into that sucker. Oh, keep it in between and then hook it. Go down. Yeah. Well, yeah. There you go.
Noodle says worm infections are his favorite kind of infections. Fuck, why is that all the way over there?
So just pay attention to your blue traces and try to snake it all the way down as far as you can go. You can go down, you can go around the left side of the chip on the blue layer.
I can do that.
Yeah, you can just route it all the way around there. Perfect.
Da,
Is that done?
No, there's 1, 2, 3, 4, 5, 6 more yellows. 6 more yellows! And then I get to put a label on it that says salmon. What time? How long have we been doing this? And I'm almost done.
Hours.
Fuck. This is actually pretty good for board routing. 2 hours now. 2 hours.
I spend days routing boards.
Hour.
So
done.
Yes.
Done. Pinch the nipples. Yeah. There you go. Does this go there? Can I go
All
there?
you can drink sake seems dangerous. Yes, it does.
We've.
It's why Uber was invented.
That was the end of most nights.
Yes.
Out with people. The night ended as it started, as it began. Where does can I put this in that hole?
Yes.
Can this red go in that
You
hole?
can put that in the hole.
Okay. How about this one?
That goes to the speaker. So run it around the pad. There you go. Perfect. Right into the side of that, or to the bottom of the game. It's up to you. Nobody's gonna know.
I'll know. I'll know. Do you like my glasses?
I love your glasses. They're sexy.
Blinks with both eyes.
Migrates, that's good enough. Get the board made.
Yes.
Well,
thank you.
We won't be able to program it because those wires aren't routed yet. So sure.
That's why they make big wires.
They make
like
good
on
earrings.
Spools. Okay. Wait.
Go
All right.
do
Now
this.
I have to do the back end of
okay.
this.
Just make sure.
Where do I put these now?
They're going to the other side chips. You just need to get it across the blue without touching anything.
But there's already a bunch of blue.
Is there shit there?
There's those
You
blues.
got room in between the. I think you're fine. Go straight down. And then you can come. You might be able to pop. Yeah, just pop that to the top from right there. And then come to the back side of the chip. Go to the right. There you go. Up, back a little, up a little. One more. There you go. Perfect. Let me do that with the other one.
Oh God, I can't tell what the fuck is going on.
It's fine.
It's fine. Just... Now what?
Same thing. Right, go down to the middle of the chip there, pop it. And then come, come all you soldiers.
Come in my face.
What?
Go.
All right.
Is it done? Wait. I starved a bunch of stuff.
Okay.
Wait.
Yeah, well, you're going to do a cleanup for a while. I wouldn't do that on the live stream. Unless you want to sit here all night.
No,
okay, get those two wires run.
What is this?
Probably power. VCC, yeah. So get that hooked into your thing. Yeah, that's a good way to go. Perfect. All right.
Wait, those are crossing now, aren't they?
Who's crossing?
Those.
Oh. Yeah, I went into the other side then. Aren't those supposed to connect together? Did that wire not get connected?
Oh, that's the back.
Oh, it's the blue. Yeah, so blue, and then, yeah, right there. The blue left. Right, up into it. Perfect. And then those two wires.
Why?
Listo. You can go all the way across and into that via, or yeah, just do whatever. And then do that last. That's gonna be the fun one. It's always the last wire you run is like, where does that go? You have a kind of a clear path that goes up that way. You can get it in between this channel. I can't see it. Can you zoom in, please? There you go.
Whoa. Wait, can I
If you can
go around that? Like here?
Underneath? I think you can. Is there anything else there? Well, we'll find out soon. Just do it. That's a little too much. I guess that's fine. And pop it to the top. No, you're gonna have to really work on that.
Mm.
You can scoot things, so just as long as you get everything connected. This is tasty.
Shut up. Slap you. What?
Nothing.
What?
At all.
There's nothing wrong with it.
There's a million DR0s. It's
Where? Where? Fuck.
all over. Like this crap is all colliding with each other.
Where?
Well, your DR0 will tell you. I wouldn't worry about it. It's just part of the process.
What?
I do the same thing. I have stuff that's all collapsing on each other, and then I run DRC, and it says, these two wires are too close, you should move them, and I do. So this is the finesse part. This takes me like a whole extra day. Because I want it to be perfect. But
This is the worst snake game.
it's in the chat bag. Yeah, it's there. They said your glasses look very much like glasses.
That's good. The chat died?
It's fine. People are still chatting. I don't know.
Oh.
Here's my card.
What?
Can you see colors with the... I think on the window it wasn't updating? I don't know. Can you see colors with those glasses? Are you going to have an emotional moment when you cry because you can see colors? No, it's not those kind of glasses.
No, but I can actually see again, which is nice.
You can't see again. Sarah would go driving and I would cross my fingers. But she couldn't read signs, so she just needed to know where she was already going.
I'm that good.
That's all fixed.
Oh god.
Yeah, what's with the on-screen chat? Did you look at it?
Nothing. I don't know what to do with all this stuff.
Oh, that's cool. It puts the chat. Yeah, they're right. The on-screen chat window is delayed by 10 minutes. Wow. I don't know. Blame the YouTube.
It's the YouTube.
YouTube. Pullis is going to bed. Thank you for joining us, Pullis.
Good night. Have sweet dreams.
Yeah, sweet dreams.
Noodle says to dream of him because he's the best.
Vigrade guesses that Chrome isn't updating the tabs or something. Could be.
Chat. Yeah, it says it should be fine. I don't know.
What's the last message in there?
It says...
In there. Yeah, the bluefin tuna thing, and it hasn't updated since. And that was like 10 minutes ago. So, done now.
Weird.
The Googles aren't working.
There.
Did it do it?
Yeah.
Oh, probably because you're editing video and that's preventing the other thing from updating, or it's not displayed so it doesn't update.
Meh.
Who knows?
Okay, so help me fix this catastrophe that I've created for myself.
Logan says he's been watching, loosely following your channel for years, and in his honest opinion, Noodle needs to walk.
Really?
Quit slacking, Robo Mom.
Oh, wow.
Thank you, Logan.
Ha!
Taylor is saying goodnight.
Oh, good night, Taylor. Sweet dreams.
Yes, you need to work on the noodle walking around Tokyo thing or something like that.
I know. Everyone, they're like, you suck, you have a 3-year-old and it can't walk, and you're bad.
Yeah.
Do I add the other motor to the legs?
Yes. That would like make the whole walk thing easier. Yeah, my theory is the chat's not updating because Sarah is in a CAD tool that may be causing the Google Chrome to stop updating its tab or something. Because when she displays it, it updates again. So I think it's just, it thinks you're idle and it's decided not to update. So, meh.
Aw.
Can you dual screen that in that mode?
I can just leave it up. I think it's because I'm minimizing it.
Yeah, that makes sense.
I know. I need to work on Noodle walking. It's been... He's
walking,
3.
Vigray says walking Wednesday should come back.
He's a 3-year-old, and I just... Yeah. The first year he was around, it was all about getting him in a shape. Second and third year were all about his feet.
Yeah.
And then making
and there's so many
better.
million other projects and ideas, and it's hard to... It's like any creative person. It's hard to juggle all the things you want to do in your lifetime.
I think last year was going to be all about walking, and the feet thing happened.
Yeah.
And then I just focused
That's
on
true.
making the feet.
Because I had the feet thing was a big deal for ours. So
it was like I had my artist residency, and what I proposed was building like the behavioral systems for a robot. So that was like what my life became about. But they're for a robot that should have been mobile already.
Yeah, he needs to walk and then start to add those things that let him be autonomous.
Well, the thing I pitched for the residency this summer
was the same thing.
Was the walking endeavor, and
so
I would
the summer of walking.
This summer is going to be the summer of Noodle book.
Better legs.
Yes.
And then he should be able to scoot.
Okay, let's do these last. How many traces are left? I think there's...
Click the rat's nest button and look at the lower left corner of the window. It says 2 arrow wires exist.
So there's this one and that one.
Yes. Okay, so your ground on your resonator got starved because you ran blue stuff around it.
Yeah.
So you need to move that blue stuff away from it and add some vias now. So zoom in on that section. So you... Oh, yeah. What is this? Oh, there's nothing blue here. All right, so time to add vias. Okay, this is the part of a circuit board where we, what is called stitching. So the problem is Sarah has a rat's nest, still 1 air wire or rat's nest wire, but it should be auto hooked up because we have a ground plane. And the reason it's not getting hooked up is all the traces now are cutting off paths to ground that need to be hooked up. And in this case is like this chip has this blue area on the bottom side, is rat's nesting to the top side, and it's partially cut off here and it goes somewhere. So when you have 2 ground planes, the solution is to stitch them, just like stitching 2 pieces of fabric together. We're going to put vias randomly in the board in different places, and that will connect the top ground plane to the bottom ground plane, and then give you more automatic paths so that everything that needs a ground or wants a ground gets a ground. So start by adding a via to your board. Click via. Click that green icon right there. All right, so
that's huge.
Our drill automatic, no, it's not. Our drill automatically came in as 12, which is good, which is what we want. It's round. So drop the via right there. All right, so now name the vias. Hit the name tool and type GND. It's a ground via. So now the air wire went away because we stitched the top of the ground plane to the bottom of the ground plane in that location.
Yay!
And so now, so your board routes, but if you want a better board with better power, better all that,
I need to get rid of that.
you need to, okay, we'll fix that. But you're going to copy that ground via, and you're going to put it anywhere there's an area where there's nothing on either layer, add those all over your board. There you go. Keep copying. There you go. You just need one per little area right there. Happy little trees. This is the Bob Ross part of our whole thing. So, so you can't have too many of these either. But your board house will hate you if you put 1,000,000.
Why?
Because it's an actual machine with a tiny drill bit drilling that. So if you use all of their 12 mil drills up, they'll be pissed at you.
Oh.
So it'll take longer to make. All right, so so you have areas here, just a few more. You don't have to go to town, but it depends on your board. But now this board will have less likely that you have a starved ground somewhere that you didn't see. So we've stitched those together.
I don't like starving.
No starving.
Scream.
Scrim.
Scrum.
You can put one there.
Okay.
All right, that's gonna probably be fine. Okay, hit rat's nest again. All right, let's
Nothing to do.
Do you want to DRC it?
There's these, and they're
So
gonna
you know
not
you
pass
have them.
DRC. Like that's a horrible turkey nest.
Neck. Well,
basket.
So see the black area?
Yeah.
As long as the blue isn't overlapping into that area, it's gonna pass DRC. So I can't see that. Can you see that?
Are you gonna DRC?
It actually looks kind of fine to me. It might DRC. So you have Lane's PC board. Yeah, his rules are good. So go with that.
Oh God, 141.
Oh, do you have values turned on?
Probably have everything turned on.
All right. So one thing is, you have T values and B values. You've got to turn that off if you're going to run DRC because, for whatever reason, they run DRC on that, but those things do not end up in your final board, and it thinks a bunch of shit overlaps when it didn't.
86.
So you cut that in half. So start at the top. There you go. There's your first one. Zoom in on that. Let your people see what you're doing. Zoom way in on that. Okay. So your via is too close to that red wire, and it tells you by how much by drawing a shape. So just scooch that to the left. Down and left. There you go. And then same thing, you have the blue here. Those two wires. You're gonna have to make that gap bigger somehow. So you're just gonna need to finesse this. But yeah, start in the middle of the chip first. And some of these collisions will generate 2, 3, or 4 DRC errors. So once you fix the problem, you might eliminate 4 errors in the process. Use your that's still really close. Yeah, see how the blue and the red overlapping? So what? See how the blue comes too close to that? You can see it through that gap.
Yes.
That gap is the space that you need. So you need to bend these wires around that via, or move that via backwards this way, which is probably the best thing to do. Just down one notch, not too much. There you go. And then rebend this wire, rekink it with your kink tool.
You're a kink tool.
I'm a kink tool. Bring it closer to the wheel and then get your 45 back. There you go. Found one. Nope. You're in the wrong mode on it. Right click to get the right mode. You don't know what mode, you're too close to it. Move the mouse away. I don't think that's right. The angle's wrong. What are you doing? Zoom in. Can you see that? I can't see that. Are your eyes better than mine?
What?
Okay. Do you see how these are parallel?
Yeah.
These are not parallel. You just clicked it and it's not parallel. So do the kink tool again. No, no, no. Down one more. All right, that's fine. All right, so that via is still in the way. You're gonna need to bring this, make this gap bigger. Well, no, you had it.
Baby gap? There.
Yeah, but now the blackout wire is too close to the via, so you're probably gonna have to move that down. Maybe it's not.
Baby gap.
Yep.
Fuck.
So you just make the blackout wire kink around that. Or move that via down a little bit. Oh, one of your jellies fell.
No.
One of the jellies fell from behind us. Ghost! We have a ghost in the house! Alright. It just gave way. The nail came out or something.
I didn't realize it's a hook.
The hook broke. We interrupt this program. Oh, those rubber bands?
Mm-hmm.
They finally give out. All those rubber bands are going to give out. They rot. Rubber rots in air. Alright. So, yeah. Clean house on that. Knock them out one by one. What? Yeah, you can accept that one. There you go. What you got there?
I don't know.
What is that? It says a drill size. What? Are they all drill sizes?
Yeah.
Oh, your lane sets the drill minimum to 13 and the Seed Studio allows 12.
Mm.
So go into your DRC rules and change it. Screw you, lane. All right. So go into sizes, drill, 12 mil. No, minimum drill. Second one, 12 mil. All right. Okay. There you go. Shorter list. Ding. All right. Fix that.
Ah!
You're making progress.
Ah!
This is the part where Sarah just screams uncontrollably.
Oh.
Like a bird. Do it from the other end. Here's a trick. Stop. Escape.
No.
Escape. No, let me tell you. Let me. Fine. That'll work. Escape. All right.
What?
There's a trick.
Ah.
No.
What is it?
Okay. So, you know this end is where it wants to be?
Yes.
So your kink tool, click on the end of the, so you have this end of the trace and that end of the trace?
Yes.
Click near this end of the trace with your kink tool.
Kink tool.
Kink tool. Now, does you see how this stays and this
Yes.
follows this? Now you can correct it.
But I did that manually.
No, but it's doing it automatically for you now.
I hate everything.
Me too.
Okay.
Let's start a club.
No.
Alright.
Morbid.
Let's wear goth makeup.
You're
Okay.
goth makeup. Check. 46.
That is acceptable because that's what it is. Okay.
Oh, I'm gonna move all those.
You gotta.
All of these are stop masks.
Yes, so fix your stop masks and then come back and do this again. So
Nah.
turn off all your traces and all that, and then
Alright, what is it?
turn everything off.
None.
Pads, vias. You can might as well click unrouted, just in case. Dimension, T place, T origins, no values, T stop. That's it. There, that's the top, and then you'll do the same thing with the bottom.
Where's the values and shit that it's yelling at me about?
They're on the bottom. It's the one. It's the resistors on the bottom that was complaining.
What the fuck
No,
is
that's the pin number. Don't worry about it.
J2? I don't want it to be named J2
okay.
or J4.
Okay,
or J4.
you're gonna need to change those in the schematic.
Where's my smash button?
And then smash them.
Smash!
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 Smash them.
Smash separates the label of the thing from the thing so you can move it away from the thing. Right? Right?
Yes. See, now you can move the word trim one and put it where you want it. You can resize it.
I want it in cursive.
Pick a font.
Yeah. Bring.
Don't put it on the via because when it drills through, that part of the silkscreen won't resolve. So that's the other thing is don't put words over those vias. They will not print right.
Scram.
Brain scram.
Brain scram.
Scram brain.
Noodle says yes. Noodle. So I need to get Noodle walking. Bad mother.
Yeah. All right, so click
Sorry,
layers and do
Noodle.
the bottom now.
Noodle.
So you're gonna do leave all the top ones. Do B place. Turn off T place. Toggle origins. Toggle names. Toggle stop.
Oh God.
There. And then smash those and fix them.
Smash.
Smash.
Why are they all on top of the thing?
Because you turned the part.
Oh. Spank bank. Thanks, Tony. I'll give you a spank bank.
Tony's a spank banker.
Tony.
I'll give you a spank
I'll
line.
show you my spank bank.
I'm a spank tank.
Right. Uh-huh.
Going to spank this way.
I'm on the right track, baby.
Oops.
What? Oh, that's
The
this.
origin of it. Oh, and then you see it.
Weird. Sure. I just put that here.
However you like.
Noodle says that mommy is good at this game. Yeah? This is the worst snake game ever. Yeah.
Yeah. So that V is gonna blow away part of the letters.
Is that a V as
Hell, you could relocate it if you're gonna reroute that wires for it.
Blinky dingle. Crotch blink. Blingle. Why? Why did it do that? Horrible, Mark. Just put the letters on top of the shapes.
Alright, let's go back to chat.
Yeah.
Rob took off.
Oh, I missed saying goodnight to Rob. Good night, Rob.
Oh, it's when the thing fell. James says he now knows what a scrum sounds like.
Yes?
You're right, James. It's ah!
Huh?
Yeah.
Ah.
Vibrator wants to start a cult. I'm in. I'm bringing the Kool-Aid.
I'll bring the donuts. Donuts. Oh, I found one of those pin cushions at the Container Store with Tony yesterday. It was a donut and the sprinkles were the pins.
That's a that's a great idea.
It was like my egg sushi, my Tobiko, but it was...
Royd took off. See you, Royd. Sorry.
Oh, good night. Sorry this didn't fruition before bedtime.
Yeah.
It's almost there. Okay, can I do DRC again?
Yes. Turn everything on except values and then run DRC. What?
Approved!
You did it.
I passed DRC!
Her board passes DRC. You can make it, and it will probably work.
It's not even midnight yet.
Check your those connections.
Yes.
I don't think they connected because we didn't run the traces between those 4 connectors.
What?
The 3 connectors.
What?
Your 3 LED connectors.
Oh.
Those traces. Well, there's one there, but I don't see the other 2 traces. Like that has nothing's connected. So see why it didn't connect in your schematic. So pick it up, move the part. Okay, that's connected. That's connected. That's connected. All right, now go look at the board again. See if we got rat's nest. Well, the blue. Oh, there's a blue layer. I didn't see that.
Yeah.
So you have.
Connected.
Are they? You have that. Where's the? Oh, I didn't see that one. Yeah, they're all okay. You're good.
Okay. Okay, let's add some text. We're gonna make the board pretty. We're gonna put the sprinkles on the salmon. We're gonna put the fat on the tuna and make it a fatty tuna. Yeah.
James says just ship it.
No. No.
You gonna call it fatty tuna?
It needs fatty boom boom.
Okay.
Okay, on the back plane, the butt plane. So none. I want the bottom. B. All right. Do I want it on the top?
What are you putting?
I want it on the top.
You're putting it on the top.
Top. Top. Top. Can't you set presets of this?
I wish you could.
I think you can.
Where would they be?
Jeff told me that you can.
They should be like buttons on the side of that window so you can just click them.
Text. I want it to say Fillet-O.
Put it on the TV, please. Put it on. Alright, and is that the size you want?
I want big.
Mega.
Thick.
Thick.
Vector.
And then do the ratio 15 for bold.
I want it to be thick, Mark. I want it to be so big. Just
there you go.
Big. I want it to be like
Fillet-O brain.
I don't know if I can handle it big.
Whoa.
That big.
Whoa.
That big.
Take you to the hospital big?
Yes. Darkness big. Is that done?
It's just called paramedics big.
That might be too big.
That was a good size.
You think so?
Yeah. It fits. It's got some margin.
Mm.
The poor house would be like, what the fuck is this?
What the hell is it's like a vagina?
It says Fillet-O and it's weirdly shaped.
Fillet-O. Yeah, it's
the guy at the factory's gonna be like, I'm making extra copies of that because I just need that.
I don't understand what I'm looking at.
She just sell fabs.
It's just weird.
Yep, it's like, hey, there's a part list on the GitHub, but just these are the fabs.
Have fun.
You just own one, just to say you have one. I would.
Fillet-O.
Fillet-O.
Now time to add salmon stripes.
Alright. That should be fun.
Wait, I need a Spetku. 2018.
Yeah, James says that the logo is a good size. It's the size of the Spank Bank connector. Taylor's still here. We thought Taylor left.
What?
He's still here. He says yay.
Go to bed, Missy. You have a long drive tomorrow.
That's right.
Ooh.
Update your chat.
What? Shit.
Is that you?
Yeah. Should it be bigger?
Yeah. Remember your sizes.
Does that look good or 150?
I like that. Bigger is better.
But is the connector gonna overlap it?
You're putting an SD card on the back side of that?
Oh yeah.
Or the top side?
The back.
It's fine then.
Should I move it down?
Well, there's just solder points there since it's the back. So you'll read that just fine.
Yeah?
Yeah.
Okay. Fillet-O. And then Spetku 2018 version 1. Yeah.
Taylor says blah.
No. This is your adventure. You're going to the place and it's gonna be fun. Yeah. What's a good size for small text? Is 50 good or is that too small?
50 is you installing Mills?
I don't know.
Yeah, it's fine.
Are you sure? You sure?
Yeah, I think
you sure?
40 and 30 are the smallest you can read.
Yeah.
Mm-hmm.
Hmm?
The delay.
I need salmon stripes.
When did this happen?
What?
Is that like 5 minutes ago?
I have no idea.
This stream is delayed by like 10 minutes, it seems like.
Oh, that's always behind. You should update it. Up,
Update my own thing?
up, 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 up. Ba, 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 ba.
Or maybe because I hit. Oh, there it goes. I wasn't live, I was watching.
Mm-hmm.
Yeah. What
Yeah.
else? Just your lines?
Yeah, I need salmon lines.
Then do it. I'm gonna go back over to my computer.
How do I? What layer do I put them on?
You put them on that place layer, T-place. If you're gonna do silk.
Okay.
Yeah.
Yes. And I do what I draw them with. I draw them with this thing.
Do you want big fat stripes?
Yeah.
Or do you want it like for the orange? Or you can leave the red color and then
red color, white solder mask.
Red color for your meat, and then just white stripes.
Yeah.
So I would just I would draw the stripes with the curve with the wire tool on T-place. Set your thickness, and then you can use your command key to make it curvy. Right?
Okay.
You might set them up as straight lines and then make them curvy, so that you at least get the endpoints where you want them according to that picture that you had.
Okay.
Does that make sense?
Yes.
So get your edges at where you want them, and then add the curves last. So use open up your reference picture. So yeah.
Now we have to match the salmon. The sacred art of salmon matching. Oh God. No.
I almost should have put the chip down. That just looked weird. There's a button. So maybe draw your border. You might be able to copy your dimension into the T-place layer and then thicken it up, and then you'll have a white border around your board. Yeah?
Yes.
Oh God.
Salmon fields forever.
So I try that. You know what I'm saying? All right. There might be a trick to copy that. So turn everything off except for dimension. All right. So zoom out a little bit. All right. So use the box tool and draw a box around it. Okay. All right. Yes. It doesn't matter. Okay, copy. Oh, set a grid to like 10 millimeters. This is going to be a fat grid. Go back to millimeters for a minute. Actually, do everything at millimeters now. So,
for what?
So 10 millimeters. Okay. Okay. Copy group. Right click, copy group. All right, move it over to the side by itself so it's clear. There you go. All right, so now draw a box around that one. And then hit the wrench, layer, up, down, layer, T-place. Okay. Right click, change group. All right, now turn all your layers back on. All right, select, I think it's selected. So now just do the move tool. Actually, make that fatter quickly. So do no, it's already, it's okay, that's fine. Do wrench with try, that's got a good thickness to it. Try like 1.27. No, that's gonna be really big. Try 1.2. You can always change it. And right click, change group. Does that look about what you want?
Yeah, that's good.
All right, so now move tool. Right click, move group. Move it back over the right click.
Because it's half off the board.
Yes, so it's gonna trim off.
So should I make it thicker?
Yeah, if you want it more visible, then double that up to 254 or something. So change.
What width?
Oh, I said width. 254. Change group. There you go.
Jesus Christ, it looks like a tooth.
Tooth board.
Yes.
Group. Flip it over. Slap it.
There, it's better.
All right. Does it obscure any of your words? No.
No.
Probably fine.
It's a salmon.
So the thing with the placement, it's gonna, DRC is gonna complain that you just
ruined everything.
You can approve those because anywhere there's a pad, they're gonna clip. The pads take priority over that, and they'll clip it out. Or they should. So.
Should I make it fatter?
I think that's an illusion.
Just a little bit.
That's up to you.
What is it now?
254, then 31 something.
381.
That's right. Fat. That's almost 2 millimeters into the edge of your board. Is that what you want? You can type in 3 if you just want 3 or 3.2. So you could say width, wrench width.
That's good. It's thick.
It's thick, honey.
Thick with C's. There.
That's pretty nice. I've been a millimeter and a half.
That's good.
All right.
I want it thick, Mark.
Yeah.
I know.
What?
Thick. Thick.
All right.
Okay, and now I need stripes
So set your grid back to 1 millimeter. And then put your stripes in.
So I'm doing straight lines.
Straight lines, and then add the curves later.
Okay, and I want them to be like 1.
Those are going to be 1 or 0.8 or something.
Where do I?
You want about half of what those are.
Where do I set the size?
Yeah, there you go. Hit the arrows, little arrows, with 0.8-ish.
1.
That's 2/3 of what you have now. I think it needs to be half of what you have, which is point. Where did 0.8 go? Just type do why? Well, make the window a little bit bigger and type in the value. There, type in. Enter. All right.
Okay, so I'm thinking. Taylor!
Taylor.
Who's here? Good night, James.
Oh, good night, James.
Good night. Thank you for hanging out with us while we make a board. Taylor, are you there? Tony, are you there? Tony, Taylor.
Tony's asleep.
No.
He's cuddling.
No. Is Tony cuddling?
Making a little mat right down
A what?
there. Mat over there.
What?
Tony,
Why? Why Matt?
Mm.
Do you want a little mat that you can cuddle? Yeah. Would that make you happy? Everybody needs a cuddle mat. Yeah?
All right.
No, don't go.
I need to do my things.
No.
You got my whole evening.
No. No. Don't do it. No.
Need to pee at least.
No peeing.
More water.
No.
And my butt's numb from this chair.
You need to
Oh God.
work out your butt.
Oh.
This is what happens when you don't work out your salmon. Circuit salmon. The only right kind of salmon. Noodle says this is wrong. How are these looking, folks? I think they look weird. Mark, look.
Ooh, pretty. Now you can bend them.
Salmon love?
Salmon log. You need more lines? Is it the same amount of lines?
No, it's fewer. But it's sectioning out all the
I see.
things.
That's cool.
So now I can bend them and make them bendy salmon.
If it's not cooperating on bend, you can set the grid a little higher.
Oh God. No. Noodle says we need to get mommy a water.
A little water.
Yeah. I think if I get Noodle walking this year... Oh God. I'm gonna throw a party for him. An epic walking party. as I get all quiet. Does that look like salmon? Oh my god, how long have I been doing this for? Since Mark has left. Let's check OBS and see. Yeah, you guys can see what I'm doing. Tony's here still. So is Taylor.
Wow.
Aw. Good night, Taylor. Oh, thank you. Thank you.
I love you.
Don't leave. Do you want
right here talking to you.
Do you want to sign off and call it a night?
I am signing off. You can call it a night. I think you made enough progress.
Okay.
Yeah?
Here, look at it and give me your blessing. Thank you for giving me water. Did you poison it?
Yes.
You did?
Yes.
What did you poison it with?
With whatever was underneath the sink.
Really?
Yes. So.
Do you like it?
Yeah, that looks like a salmon. It's not exact.
What?
The bottom part on the other one. I guess. Sure.
What does it need more of?
I don't know. It needs more stripes, I think.
Really? Like how many more?
Like the same amount.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 1, 2, 3, 4, 5, 6, 7.
So 3 more.
Really? What do you guys think? Whoever's left. Ah, I'm here just on a different computer than the one I'm using to watch this stream. Aw, I'm glad that you're still with us, Vi. Need less distractions to do the walking codes. Yes, I do. That's not even on my list. Neither is my comic. I made those to-do lists today, and they're, like, long. And Noodle walking and my comic are not anywhere on any of the 4 of them. I don't know which ones they would go on. Alex says that he's just got here. I routed a board. It's this one that's on the screen. The salmon. I'm trying to match up the silk so that it looks like this salmon right here. That's what I'm doing at the moment. But over the past X amount of... how many hours? How many hours have I been doing this? 3. Okay. 3 hours I routed this board. And chatted a little bit. Aw. Maybe I should upload it. Yes. I think it could use more. Alright, it's still up sometimes. I know, I'm amazed I don't want to go to sleep either. It's almost midnight, which is kind of bedtime, so I don't know, in the next 15 minutes or so after I add 3 more stripes to the salmon, I'll go to bed. I promise. Right, Mark? Yeah? Salmon. Salmon. Cool. And Tony's still with us. And Taylor, I'm not sure if she went to bed yet or not. But if you're still here, then hi. I'm gonna add 3 more salmon stripes, and then I'm gonna call it mostly done and go to bed. And tomorrow, well, you guys aren't on the stream, I'm gonna go through and meticulously make sure that all the things that need to be symmetrical aren't symmetrical by typing in numbers, but that's boring, so I'm not gonna do that now. Oh, and to answer your question, Alex, the board is, it's responsible for, it's going in a pair of robot panties that will whisper sound from a WAV file that's on an SD card into the wearer of the panties. And it's going to do so to volume equal to the wearer's heart rate. So the higher your heart rate, the louder it will whisper into your crotch, and the louder the whispers, the more there's vibration, ultimately. So that's what this is doing. But the robot panties kind of look like a fillet of fish, consequently, which wasn't intended, but since they do happen to look that way, I figured I might as well name the board that I'm designing to run the panty circuit the Fillet-O fish. Because we all have good humor here. We're classy. With a Z. But anyhow, 3 more stripes. Bump it, Sarah. Yeah? How about this? Let's turn off everything except for top and then the T-place. There, that's easier. No. Or how about not top? There. Hmm. I think I'm going to skip one here so that it doesn't overlap my nice text that I've got going on. So I 1, 2, skipping the 3rd. So I've got 4. This looks like it could go up a little bit. No. Mark, what's the most exotic board you've ever designed?
Exotic?
Yeah.
What do you mean by exotic?
I don't know. Really.
Exotic. I think one that reminds me of this board is when I worked at Sun, we were making a book. It was a system for answering your phone and taking messages.
Okay.
Does that make sense? It was supposed to be a computer that you put on your phone line, and it would get your email for you. It would take your phone messages like an answering machine, and then it would forward information. And the thing is, we have stuff like that today, like Google Voice and all that. But back then, before there was Google Voice or anything, we imagined a machine that you put on your phone line at home, and it would manage all your messages and your voicemails and forward them to you. Stuff. So it was a little box called Persona, and it was a little round M&M. You know the M&M guys from the commercial?
Yeah.
It looked like that. It was a round M&M box with feet, and it was almost like a little character, right? And it sat somewhere in your house, and it answered your phone calls for you. It had a voicemail system and all that. And they were trying to bring that. It never made it to products. It fell apart. The guy who envisioned it left the group for some other job. So it was a shitty thing to do because, well, if you envision it and you get the management to give you the money and the budget to do all that, and then halfway through the project you decide some other better opportunity came along and abandon your own project, the thing's gonna fall apart, and it did. The whole project fell apart. It was horribly managed after that. So it died a quiet and prudent death. But it was a prototype that never made more than 10 of them, I think. But that was the most exotic because it was this roundish board with all these curves, and it had to fit in a round box, and that was the most exotic thing I had, like challenge that I had, because I'd done rectangular boards up into that point. So that was one of the more interesting things I ever designed.
Gotcha.
So, but it's sad that it never existed beyond some prototypes. My life is full of failures. Failed projects from Sun Microsystems.
Mark's not bitter.
No.
Mark loves Sun.
It was a fun place to work, but it had its hard edges.
Just like Mark.
Right?
I'm joking. Mark's nothing but soft edges.
So I'm told.
You're fluffy. Honey.
Yeah.
You're fluffy.
Fluffy.
Floufy.
Floofy.
You're floufy.
Fluffin.
You're a flouf.
Fluffin, schlaffen.
Would you like to flouf? I would like to flouf, sir.
I should get some of my old circuit boards over there.
You should do a stream. You should show off all of your cool stuff that you have. What the hell is that? I don't even know. I don't want to know what that is. It'll ruin my night. I think that's enough stripes. I'm gonna call it done. It's done. I don't want to overdo it. Except these are now overlapped. Let's stick you here. And move it. No. Ugh. I can put these on separate lines. Properties. SpetQ. Yes. It's going to say SpetQ, and then I can do another one that says 2018, and then version 1 can go underneath that, and then everyone's happy, and all the text is mashed onto the board. And then let's put SpetQ over. No, I like that down. SpetQ 2018 version 1 can go over on this side of the board, or up here, or something. There. I like it. It's done. All the information I want is on it. Now I just need to figure out where these drill things are going to go. Fuck. All. Except for those weird ones that you added that are bright blue. Why did you add those? 3D ref. Weird. Aw. I recommend making the salmon stripes a little closer together to accommodate for the 3 extra lines, even if it separates components and such so closer. Okay. I mean, I think, wait, 1, 2, 3, 4, 5, 6, 7, 8. Ah! I don't have 10, but I've got 8 in there. I think any more might make it look too busy. I might give it a try tomorrow, but I'm gonna call it done for now. I get to... I just want to take over and get the lines done in a particular way. Aw, I feel the same way. Tony, oh, it sounds bad when someone talks from the other side of that mic. Oh, you can't hear Mark? I need to just get a big room mic. I approve. Yeah. Aw, thank you, Taylor. I'm glad you like the salmon. I'm happy that the board came together pretty much like in one evening, like from start to finish. And it looks like what I drew, which is always super cool. Thank you for sticking around and watching the process. I'm happy that you guys are around to see a night of Mark doing what he does do, helping me. Yeah, usually this is how it ends up when if I'm routing a board and I have to do so expediently, he usually ends up standing over my shoulder and barking out commands. So that was going to be a thing tonight. So while we were cooking dinner, we both decided on a whim to just sort of do it in this format and stream it because, I don't know, we were drinking at the time and it sounded fun. Oh, wait, you're going to bed?
No.
But you're signing off of what? Oh, you're peeing?
Yeah.
Oh, he's gonna dump. Mark's dumping. No. All right, bye. Bye, Mark. Enjoy your trip. He took his phone. We're never gonna see him again. Oh no. All right, well, if I needed any board help, it's not gonna happen for a while. All right, guys. Shit. But yes, thank you for staying up with me and being part of the process and giving me your feedback. Cool. By Gray says he approves of the design choice for the stripes and the spacing, so good. I think, I don't know, with that, if I can get approval and your blessing on it, guys, then I think it's done. I'm probably gonna go back and, again, like I said, make sure that the holes are in the right place, because they're totally not right now. They're all like durr. I'm gonna make sure stuff is symmetrical, and then once I give it a second pass, I'm probably just gonna send it off. And I'm thinking I'm gonna have it made in red. It's not orange, but I think a red solder mask with white, silk on top will look a lot better than getting it done in white and then coloring it with Sharpie like I was originally saying I was going to do, because the silk will be in black if I get a white board, and I don't think that'll be as interesting looking as red with white on top, especially with these nice white, thick, chunky lines. So, I don't know. I think it'll look good. Be a red salmon. Take your time, Mark. He's gonna play that coin drop game. Like, I know that he sits on his phone and he plays that, like, coin pushing game where, like, the arm slides back and forth and you have to, like, tell it when to push so that it might knock the coins off of the edge. I don't know what those are called, but that's, like, his addiction. I'm outing him right now. Oh, you do? Vi says he knows where I might be able to get orange boards. If I can get them fast and inexpensively, then that's awesome. Otherwise, I'm just gonna go with seed. So I do need them by the end of, well, no, I'm not even gonna say by the end of May. I need them by, like, as early in May as I can possibly get. Like, the sooner the better. I think for, like, this rev for version 1, I am just going to do, like, go with seed and just have them. I'll, like, piggyback on Mark's order like he was saying, and then I can just have them. But yeah, salmon shouldn't have too big of stripes, as that represents lower quality of fish. Oh no, I don't want my salmon to be low quality. I know someone who got super hot pink and they had a lot of options. The person who knows might be trying to keep the place a secret though, so he is the one with access to cool colors. They might not be cheap. Yeah, I don't know. I mean, I think eventually, like, when I get finals of these boards made, or not finals, but, like, if I exhibit them somewhere and I want to have fancy versions made, then I might go with a bit more expensive board house and, like, get the nice, bright, like, fancy pants colors. But right now, this is probably going to be fine. Yeah, I just want to have them in time for the thing I'm going to in Tokyo. Like, I would like to bring this and show it off in some capacity, so if I have nice custom boards to display in the thing, that would be great. Because otherwise I'm just going to end up wiring this up on some perf board, and that's kind of jank. But I'd do it. Meh. No reason not to have a nice salmon to in your box to show all the people that you don't know. But yeah. I don't know. I like the big striped salmon. It'll do. It's like a nice cartoon, highly suggestive shape that I'm kind of happy with. It's like layers of innuendo piled on top of each other. It's the beat box in the robot. It's like robot panties called the beat box with the fish board called the Fillet-O, and it's like a cross section, which is like, I get max points. I'm sure I'll come up with more things between now and when I leave. But the other thing, I guess I can show this before I sign off. I've got like a minute before I'm gonna call it. But if I do stream tomorrow during the day for a little bit before we go to lunch with my ma'am, oh god. This came in the mail with my new glasses, but I didn't open it yet. Here, let me switch over so you get this thing right here. This is red transparent vinyl. So I'm making this backpack that's going to be the enclosure for the brain, like the main brain circuit board for this wearable. And I can't find one to buy, and I was bitching about that on Twitter the other day, because I looked. I went on Amazon, and I hunted around for, I don't know, an hour, couldn't find anything, and then just said, fuck it, I'll make one. If I go to back to my desktop view and show you the concept art again. So I've got the Fillet-O board. If I go to the pulse pack, there's like this heart thing in it with wires coming out of it. It's basically like the main brain that's going to run all of the peripherals for the Shibon project, or the Shibon project. And then this is basically what it's going to be. It's going to be like a vinyl, like plastic transparent backpack with a heart-shaped PCB in the middle, and then all the wires will be running to the edge of the backpack as like strain relief, and then wires will be coming off the edge of the backpack and going to all the respective places. But this is the red vinyl that I ordered that came in the mail, and it's way longer than I expected it to be, but at least it's nicely rolled, so it's not going to be all creased and crinkled, and I can use this to make my fancy backpack. So hopefully it's thick enough and it looks nice, and I don't have too much of a hard time figuring out how to stitch pieces together. So that's probably going to be my project for this week. Yeah. But anyhow, I don't know. With that, it's midnight, so I'm going to probably call this stream done and get ready for bed, because this is, again, Sarah's bedtime. But the board is done. Yay. The salmon is in a shape. I'm gonna probably, here, let me go back to the, nope, yes, okay. Go back to the concept art. I can end on this note. So for comparison, this is the concept sketch for the board, and then this is the board itself, how it is as of tonight. You can post a before and after shot. And I fit all of the tiny pieces in my salmon. And I'm gonna give Mark a super big hug for helping me. Anyhow, okay. Go to bed, Sarah. You're tired. Save. Alright, guys. Let me check the chat one more time. Ah, Taylor says she's eating salmon sushi right now. I am super, super jealous. I'm probably gonna have some midnight cheese, I'll be honest. Because it is actually technically midnight, and I'm hungry. Okay, and Vi says to check my Twitter DM. I will do that, for certainly. Oh, and that's annoying, it's auto-focusing. I guess I forgot to turn that off. Doesn't matter now. Alright, guys. Sleep well. Taylor, get some rest. You know, finish packing and then, like, have some tea and, like, get some good rest. Vi, good night. I will check my Twitter here in a second. And cool. Alright, guys. Take it easy. I'll see you.